Well, this seems like a pretty good time to come in, just before the drop. How is everyone doing today? Hope you're doing well. Off to a good start with our second stream of the year, 2021. It started out a bit crazy, referring to the events in the US. As a Canadian myself, I'm somewhat impartial to things that happen there. But in this particular scenario, I was quite upset, along with a lot of other people. But as this is not a stream about politics, I think we'll just skim over that. So for anyone who is watching, welcome. I'm Matty Two Shoes, or Matty, formerly known as Matthew. I am a full stack analyst, self-titled full stack analyst. It means I deal in all things data. And today on Twitch we are going to be looking at movies. Obviously for copyright reasons we're not going to be watching movies together, although that would also be a cool idea. No, we're going to be looking at the data behind movies. I have a data set today from IMDB, one of the largest, if not the largest, movie database in the world. Movie and TV show, actually, and shorts, and all kinds of formats. And that's what we're going to be looking at today. Do let me know if the music is too loud or too quiet, or if you'd like to change it. I'm open to suggestions. Personally, I like electronic music, so that's why I play electronic music on the stream. But yeah, if you have any suggestions for what you'd like to listen to, do let me know. Once in a while I need to hydrate and make sure my throat is lubricated. So that's what you might hear me doing. Because I do have this beautiful metal bottle, but it's a little bit noisy. Might need to invest in a different one just for streaming. If you are new to the channel and have not seen a stream of mine before, welcome for the first time. Thank you for being here. And in my channel, I like to share my knowledge about data and analytics with the world, and hope that I can also learn from you by asking questions. And the main reason I'm on Twitch is because our field is very popular, but there's not a lot of people who actually do what we do. And therefore, it's kind of out of reach for a lot of people to understand what we actually deal with every day. As you know, being in a digital analyst or data analyst or data engineer or any number of titles that fall into the data and analytics spectrum as a whole. So that is, that is the gist of it. And one other thing is that also educational opportunities are quite limited. Also here in Switzerland or in Europe in general, I think stateside, like North America, it's a little bit different, but certainly here in Europe, the formal education possibilities for someone looking to get into this field are very limited. And I feel like I've been given the opportunity in the past, over the past 10 years or so that I've been working in this field, I've been given the opportunity by many people to learn from them and their experience, and so I'd like to pass that on. So I do welcome all questions in chat. I try to look at the chat often, even if I'm writing SQL. I do try to peek over at the chat. And so I think we'll just go ahead and take a look at what we are going to be looking at in today's stream. Yeah. So we were saying movies. What do we mean by that? Well, we have a very, very cool and very, very large, we'll come to the size in a moment, data set from IMDB. IMDB directly provides this data set, so you can actually go download it yourself as well. I've listed the URL here. I will also paste it briefly in chat. So the main thing that we have from IMDB is movie titles, actors, ratings, and also we actually have kind of the link between which actors were in which title, or which movie rather. I will probably interchangeably use the words title and movie because the way the data set is named, but yeah, basically that's neither here nor there. Some things I wrote down, and if you're not familiar with my stream, I start out with this short overview of just explaining what data set I'm working with today. That won't always be the case. Streams in the future will be probably about little bit different topics as well, like data collection, so like debugging a website, figuring out what kind of data they're collecting, in what way, with which tools, also specifically some tools and methods like server-side collection, maybe with Google Tag Manager, or even other server-side mechanisms. Yeah, more data analysis focused, maybe already using a data set that's already engineered and looking at visualization, which is an area that I need to improve on a lot as well. So that's, yeah, those are all possibilities. Depends on what you guys want to see, of course. I have a suggestion box on my Twitch profile now where you can put in things that you would like to see on stream or things about the stream itself that you'd like to improve. Yeah, I'm really curious to hear your feedback on that. And so some potential questions that I write down, I introduce the data set, and then I think about what kind of questions I want to ask that data. It's a little bit like interviewing a person who can't speak, but can just show you things. Like, these are my arms, these are my legs. That's how I kind of think about when I approach a data set that's unknown to me. And so the main question for me is like, you know, are there some really cool things that we can figure out? This is a big question mark. I really don't know. I've done a little bit of pre-exploration with the data set, but not a lot, just enough to familiarize myself with the columns, but that's basically it. So I didn't want to go too far as well, because I also want to include that part today in my stream that I didn't include the last few times, which is actually kind of debugging the data set first to figure out the quality of the data set that we have. That's something that, for example, is very critical in data analysis, and even more so in things like data science projects or products, where that data is going to be engineered into something that may even be used on the website or product itself again. And so the accuracy of that data is kind of very important, detrimental actually, to the success of that product. So one of my fellow streamers, Carl, he spent some time talking about Q&A a few weeks back on one of his streams. I will actually link to his stream as well, because I think the kind of work that he does is also very important on the data science side. But yeah, I mean, today we are more sort of on a purely analytical path, and not hardcore statistics. What other questions do we have? So besides the QA part, what are the cool things we can figure out? For example, do the number of actors in a movie make it better rated? You might laugh, like me, chuckling, thinking, well, surely you can't just slap more actors into a movie, but who knows? It may be that the number of actors in a movie, at least there is a correlation. It doesn't mean it's because of that. As I mentioned many times before, correlation and causation are two very different things. Just because we find two things that are correlated doesn't mean that it is one is causing the other. But there can be some deductions made from that information. And so a lot of the things that we look at are correlations between two dimensions, but we also do a lot of segmentation. And if we are able to derive some time-based metrics, like ratings, if we had them in a sort of nice time series, then we might be able to even come up with like what types of movies perform best over time or something like that. I don't think we have data like that today, but let's of course take a look in the exploration part ourselves. And well, is Die Hard still the best movie of all time? Personally, it's one of my favorites. Being just after Christmas, it's something that a lot of people tend to watch around Christmas time. And yes, it is a Christmas movie, according to a lot of surveys and a lot of analysis that you can find online. Die Hard is a Christmas movie. I just wrote this down more of as a joke. So looking at the data set that we have, we will obviously look in detail in our IDE in a second, but just to give you an idea, so it's from IMDB itself. They offer a kind of web interface where you can download these, basically zip files, tar.gzs, and you can do this analysis yourself as well. You can use this data for whatever purpose you want, obviously non-commercial, but you can do anything privately that you want with it. And so we have a title basics table, or rather title basics dataset, which we've loaded as a table, which contains some information about titles. So this includes movies, this includes TV series, episodes, some kind of videos like documentaries, short films, etc. Some interesting flags here, like is adult, for example. So we could even do some analysis of adult movies, which is kind of funny. Then we have a data set about the title crew. So this is the director and writer information for all the titles. So we already see that they've thought about how to join these together. So there's this tconst, which is the identifier of the title. I will go over this again in the actual stream about identifiers and things like that, but just keeping that in the back of your mind. There's directors and writers, which is a array format. So because of multiple directors, multiple writers on a movie, often. Then there's the ratings. So this is the rating and votes information. So there's an average rating and the number of votes. So as I said, I don't think it's possible to have a time series data set of when votes were cast and what vote was given. I think that would be a fairly large data set, to be fair, and it would also be kind of detrimental to IMDb to give that out, because that's a core part of their product as well. So that's like a ratings table, which again we can tie back to the title, because we have this tconst. So that's that's quite nice. The last table we have is this name basics. This is kind of interesting. They basically refer to people as names. And then there's a nconst, which is a alphanumeric unique identifier for the name or person. Then there's this primary name. There's even birth years, professions, which is an array. Sorry, I'm just going to forward the music here. Sometimes there's talking in these tracks. So, yeah, and there's this primary profession, which is an array of the top 3 professions of that person, and known for titles. And this is very interesting because this array of tconst is basically all the titles that that person is known for. So this is where it comes together about what titles a person appeared in, and then you also have the director and writer of those titles. So you can inherently infer the role of that person in that title when they were a director, when they were a writer, or something else. I think there probably is another data set, I might have not obtained it or downloaded it, about all of the roles within a title. So this is just director and just writer. Technically, there's all the other roles that you see in the in the rolling credits. But yeah, I didn't download that, or they didn't have it available. And I mean, that's something fairly advanced anyway. So yeah, I think we'll move on over to our IDE, as it were. Oh, music just lagged a little bit, sorry about that. And so if we go over to that, we can take a look at how we actually use this data. So this is sort of the QA part of the data that I didn't cover in some of my last streams. And that's something I think is fairly important because it doesn't tell you how to use the data directly, but it tells you what kind of quality the data has, which directly affects how you use that data. So just give me 1 second to get set up here. Just need to do one small thing. All right, so I think we're ready to go. If you are watching and you have questions, of course, always write in chat. Let me know that you're here. Let me know where you're from. Curious to know those kinds of things about my audience, being a data analyst, as it were. So this is the QA portion of working with the data set. And here on the left-hand side of my screen, you will see this IMDB schema. If you haven't been in a stream yet of mine, then I'll also go over this very briefly. I've set up a Postgres database. Postgres is one type of database of structured data, where data lives in columns and rows, which is very organized, hence structured. I prefer Postgres over other types like MySQL because it has good performance and handles large amounts of data quite easily, and it has some very good functions that are inherent in its SQL language. Like MySQL or Microsoft SQL Server or Redshift, they all share SQL but different flavors. And Postgres' SQL flavor is very familiar to me, having worked with it the last 3 years. So I use Postgres. I'm running it within a Docker container. So that's a virtualized container on my machine. That just enables me to shut it down very easily when I'm not using it. Outside of streaming, for example, if I don't need it, then I can just shut that container down and then fire it up again next time, which is very convenient for me. I will also show the visualization and BI tool that I'm going to be showing later is also running in that Docker as its own container, and they basically connect to each other on my machine, and it just allows me to run these kinds of applications without installing a lot of dependencies and installing a lot of things on my machine itself. So if at any point I decide to go from Postgres to MySQL, for example, that would be very easy to do. So we have these data sets that we used in previous streams that we may use again in the future, like weather data or Swiss topographical data about streets and accidents and information about postcodes and different cantons in Switzerland. But yeah, today we are looking at this IMDB schema. And in this IMDB schema, we have 4 tables. The first table we imported was this title basics, which, if you remember from the short intro, was a table about all the titles on IMDb with some basic information about them. When I imported this table into my Postgres database, I had 5,032 errors. I actually had a lot more initially, and I spent some time debugging that to try and change some of the formatting in the file and reduce the amount of errors. But essentially, I'm not able to get rid of these 5,000 errors without a lot of effort. And considering that it's only about 0.07% of the entire data set, I'm happy with that result. Statistically speaking, this is relatively negligible for, let's say, our analytical purposes. But of course, you know, in different contexts, like if this was, I don't know, COVID-19 vaccine data about, you know, everyone who's gotten the vaccine, and you're trying to determine, I don't know, side effects or something like that, it would be maybe not acceptable for that kind of error rate. But for our purposes of showing something on stream and explaining how data analytics works, I think it's totally fine. Yeah. So this title basics table is basically everything about, I'll just open it up so we can see it. Everything about titles on IMDb. We've got an identifier, a title type, which we'll come back to, a primary title, an original title, this flag of whether it's an adult film or not, the start and end year. So obviously if it's a TV series, it could have run for several years. Hey Sharpclaw, thank you for joining. So we're looking at movies today. I was just explaining a little bit about this titles data set that we have, which is all the titles from IMDb. So we have the start and end year, which obviously for a movie will only have a start year. And you can see here there's some funny formatting that we're going to have to deal with later. And there's also a runtime in minutes, which is very useful. This is one of the only metrics that we have available to us. And then there's the genres that this title falls into. And this is actually, well, it's an aggregation. It could be multiple. So we might have to actually work with an SQL function to split these out into individual values. How are you today, Sharpclaw? Have you been enjoying your weekend so far? I had a great day today. I had pizza for dinner, so I'm extremely happy about that. And now I'm again happy to be streaming on Twitch. So this is this title basics table. I imported the other tables. They're relatively unremarkable in terms of errors. So title crew and title ratings. As we discussed before, the crew is the information about the directors and the writers in each title, and the ratings are the ratings for each title, which interestingly enough also includes the number of votes. And this is as of today. This data set, I downloaded it this morning, so we can say that these votes have been cast until, I assume, yesterday, as they update the data daily. So that's quite cool that we have this number of votes as well. But the rating is an average, Unfortunately, we don't have like median, min, max, or other information for each movie or title. We just have this average. So that may limit our analysis to some extent. So the other table in terms of QA, name basics. So this is the table about the people, or they refer to them as names. And just before we look at that table, so I had 1100 errors while importing this. Again, these are like formatting errors or certain aliases in the names or something like that that didn't play well with my import. I tried to reduce that. It was a little bit higher initially. I reduced it a little bit, but all in all, this is 0.01% of the data set. And as I said before, in an analytics context like we have today, this is totally acceptable for me to have maybe even 1%, 1% error rate in a data set. But here we're talking about 0.01%, so it's really not a problem for me. And this name basics table, so basically has an identifier for each person, has these primary professions, which is very interesting as well. I hadn't really thought about the fact that some people might not even be actresses or actors. They might actually be, things like makeup, and where we talked about the crew table not being able to link. I mean, we can only link the directors and writers. With this table, we can actually theoretically map all the roles in a movie to people, because that person has a primary profession, and that primary profession is then also with the known for titles. But of course, it would be kind of implicit. We would be assuming that they were the writer, director, writer, actor in all of these movies, which is very often not the case. We also have the birth and death years, if they have passed away. So we could also do some very interesting analysis about, for example, age at the time of movie release of the actors, because we know that their birth year, and we know when the movies were released within this title basics table. So this start year is basically the release year. I don't have the actual release date, but I think that's okay, to be honest. But so that is the first thing that we do when we look at this data set, is we figure out, do we have good data? What's the quality of that data set? And this is just one way, right, is looking at the import. The next thing we need to start doing is figuring out, for each table that we have, what kind of data do we have? So we did have a lot of information in the if I just cut back here to the intro document, we did have a lot of data about here that they actually describe these columns, which is great, but we don't know how much data we're working with. So we know what the data is, and this is like the best case scenario, really, that all this is described in detail. So start year represents the release year of a title. So you see, like, we don't need to kind of figure out what it is. We know what it is based on the definition here. But we don't know how much data we're dealing with and what kind of data we're looking at. So going back to our editor here, we can actually start in my analysis work. The first thing that I do is I start to look at what kind of data are we looking at. And for that, we're just going to start with the title basics table. Oh, I have to actually write the schema here. The reason I have to write the schema is because I actually haven't selected it here. I could technically switch up here to IMDB. And then I wouldn't need to write it, but well, it's not so important. Let's put it that way. So I know that my partner might actually be watching today my stream, because she is very interested in horror movies. she loves everything to do with horror and slasher and gore. And she really knows a lot about movies. And I told her that she doesn't have to watch it necessarily, but I was going to spend some time looking at some horror titles as part of my stream today, so that she can go back and watch the video if she doesn't have time today to watch the stream live, that she can go back. But it means that we are going to spend a few minutes looking at some titles in particular from the horror genre. But if you have some suggestions of some other genres you'd like to look at, obviously movies is a huge spectrum. We could even look at TV series if we wanted to. I wanted to look at movies today first, as I also enjoy watching movies, and of course we all miss going to the cinema in person. So this is actually a way for me to also get a bit closer to movies rather than just streaming them on Netflix or whatever. So we will spend a little bit of time on horror. I'm also going to be looking at Die Hard movies because I'm very interested about how they perform in relation to other movies in that segment of sort of action. But yeah, let's get started with, let's do one step at a time. And like I said, very happy to hear from people in chat. Katarina, if you're still here, hope you're doing well. So let's get started. I like to give my tables aliases, but I don't actually use the alias, AS function between the two. I just tend to give them aliases like this. But best practice would, of course, be if I did it like this. But just for you to understand how I write my SQL. So the first thing we're going to look at is, if I look at this table, let's just bring up a little preview here. I like to do this with sort of limit 10 just to bring up a little preview here underneath, but I could do the same by opening a tab to the right with the actual table. But seeing as I'm streaming, I think it would make it very hard to see with the two panels. Personally, when I use my monitor, it's an ultra-wide monitor, so I'm able to have the table open on the right and my query on the left. But I understand that for this 16:9 ratio, that's a little bit squeezed. So even if I were to pull like this window over here a little bit and stuff like that, yeah, it's still a bit too tight. So anyway, I like to do this limit 10, gives me a little preview below. What do I want to look at? I want to figure out, first of all, how good their ID system is. And that's very easy to do. They've told me that this ID is alphanumeric, unique in the whole table. So what I do is I do a count 1, which gives me the number of rows in the table, which I then copy. And I just put here in my notes below. Normally, if I was going to keep these for later, I would write them somewhere else, but I really don't need to keep them. I have some scribbles in a Google Sheet, which we might bring up later if we do some quick visualization or quick math. It's also very helpful. But yeah, for the moment, I'll just write these notes down here. So we know how many rows are in the table. And we're looking at a not insignificant amount. We have 7.5 million titles almost, which is a lot. It's really a lot. And I think the oldest one is something like 1800 something. We can actually look at that if we were really curious. We could just take the min start year. 1874 is the earliest. So let's take the I'll write it as min start year, just so we have it as a clean record. So that's pretty cool. And just out of curiosity, what is listed in here? The max start year. So this is a bit tricky with this /n. This is something I've already noticed now. I'll come back to that in a second. Let's do this in a second. For the moment, I had this count 1, which told me the number of rows. Now what I can do is do a count of this tconst, which is basically the ID that they've that they've said is distinct, or unique rather. And now I'm going to test that theory, or test that hypothesis at least, or statement that they've said, and say, give me the count of how many rows have a t-const, so how many t-consts do I have, and how many distinct t-consts do I have. This should give me the same number as here, which means every row has an ID, and every row is unique. Hey, Kvikende, nice to see you here. Glad you could join. Are you joining for the first time? I'm just waiting for this query to execute because it is a large data set. So we do have the same number of rows here as we do in the total database. It's great that you're joining for the first time. Oh, and thank you so much for the follow. I really appreciate that. So if you do have some questions about what I'm doing, feel free to write in chat. That's the whole point of streaming, not just doing this on my own. We're looking at a data set from IMDB today. At the moment, this title basics table, I am doing some basic data checks to see what kind of data that we're working with before we go and do some analysis of different types of movies, not just Die Hard, obviously. So the first thing we found out is that the unique identifier that they say is unique is unique. So that's very good. Oh, we use that IMDB database in class. Oh, that's very interesting. What class are you referring to? That's quite cool. That you use the kind of real-world data set in your studies. So now that we've determined that this column is distinct and unique, we know that we can use it as an identifier, which is really cool. So one thing that I noticed before is when we did this max start year, that we actually got this \n. And so if we actually open the table, we can actually see this \n. That's the notation that they have used to tell us that a field is null. Null, as we know, or if you are not familiar, a field in a database can be in two states: null or not null. Null essentially means it's empty, no information. And not null means it has information. Those are the only two states possible. And what's very interesting is that not null can be in a lot of different formats. So it can be string, it can be integer, it can be a lot of different types of things. Null is only null. There's nothing else. It's basically a type of that particular field. The column can be anything. The column could be an integer, the column could be a string, anything. But that field will be null, and it's a inherent function of the database. So if I want to use that, I can actually say where start year is not null, and I would be able to query all the fields where start year is not null. The introductory database class at the University of Oslo, where I did my bachelor. What IDE is this? So I'm using JetBrains' data grip. JetBrains is pretty big. They make about 10 or 15 different IDEs. PyCharm, a couple others that are used in a lot of different development. A lot of different development code types of jobs and applications. I run a material theme because I think it looks really nice. I think it's a bit easier on the eyes. But if you have suggestions for other themes that you like, I'm open to using other themes as well. So what we see is that this is not null doesn't work because the field is not nulled. Like this \n is not a null, right? If we wanted to see actually null, we would look at, for example, one of these other tables. I thought I saw, was it in the name? I think it was a different data set. Oh no, it was here, for example. So in this row here, we can see with these small chevrons on each side, null, that is the actual data type null. That's basically the database telling us there is no information stored in this field. And that's very important when we do analysis to know which fields are null. But unfortunately, we're not able to do that with the start year because it has this \n. So what we actually have to do is just use a standard where clause with, oh, this is not cooperating with me, with a standard, wow, what's happening here? Just trying to do a backslash, and it's not letting me do this. I'm going to copy it instead. I'm not sure why that's not working. But basically, if I take \n and say, okay, give me all the start years where it's not \n, that's kind of simulating the null function. Of course, it's not a null function, it's just a standard filtering function when we use where. But we can see that the max start year, so basically any title that is stored in IMDB, we actually have titles all the way into the future when some of us might not even be here anymore, which is kind of funny. I didn't think it would be that far ahead. But we can also kind of look into the future. Understandingly, we wouldn't have ratings for those titles yet because they haven't been released yet. So it might make sense for us to actually say, when we do some kind of analysis, that we don't want, I don't know, where the start year is not known, and something like start year is, I don't know, less than 2020 or something like that. I don't know, it might make sense to look at anything that was released previous to this global pandemic, but this is more of a analysis situation and not this sort of QA situation. And just to summarize, what we're doing right now is basically getting an idea of the data set that we're working with, so that when we do start doing some analytical stuff with the data, that we don't make a basic mistake and like assume, for example, that the IMDB ID that they gave us is unique when in fact it's not, or something like that. So this is like getting to know the person who is Title Basics, if the table was a person. Can you get one example title of one of these future films? Oh yeah, sure, we could look at that. You're right that I'm also a little bit curious. So let's do where start year is greater than 2021. So this is technically stuff that should be coming out past this year. Could take a look here. So there's a couple of movies like The Flash, which are set for 2022. I think we should go a little bit further. We should definitely look at like stuff that's like past 2100. I don't know how they're able to plan 80 years in the future. Oh, that's interesting. So there's definitely some short movie planned, and this is like the classic scenario that we would have also seen in the analysis. If we had grouped the films by start year, so this is something we probably would have done a little bit later, but we can also do it now. We can basically just number of titles. We can basically find out where the outliers are going to be. So let's say past 2020. Oh yeah, and I always forget my group by statements, I'm sorry. It's just a sickness. We can actually figure out where the majority of these titles are going to be. So 2021, this year, there's 21,000 titles. Then you see it drops off radically, and there are, as we saw, only one title actually beyond, like, let's say the 10-year horizon, which makes sense. I don't see how someone could possibly plan to release something in 2115, but hey, maybe they've, you know, made arrangements for that. I don't know. It's kind of fascinating when you think about it. But yeah, I think we can definitely figure out later more about this movie if we wanted to. maybe Kvikende says, wonder if they have already found their cast. Well, you know, they might like have the casting call set up for like 2050 or something, so that they want actors who are in 2015. By that time they're like 70 years old or something like that. I don't know. I mean, there's a lot of complications behind planning a movie in the future that I'm not familiar with, but so this is something that we can do. We could do the same thing with something like end year, where we could say the end year is not null, and I don't know, the end year, why does it keep completing that for me? The end year was, I don't know, before 2020, for example, or let's say before 2021, we could include stuff from last year. And we can order this as well, just to see where most stuff came out. And you see, like, for example, 2017, 4,900 titles. So it, I would say, like, tended to sort of increase over time, but you can see that stuff gets a bit jumbled here. So it's not necessarily the case. And we could start visualizing this and stuff, but we'll get to that later today for sure. I just wanted to spend a little bit more time figuring out if this data set is okay to work with, and also just getting to know a little bit more about the data. So we did some stuff with the start and end years, which I think is good. The titles, let's be honest, we're not like natural language processing experts or anything like that. So I'm not going to be able to, I'm not going to be able to really figure out anything about the titles if I don't do any crazy processing stuff. So we'll skip that. What I wanted to definitely look at is this title type. This is going to be very important for us. And so what I can do is I can actually look at the title type and then count the number of titles that we have by title type. And I'm not going to forget the group by this time. And then we can actually figure out, okay, how many movies do we have? How many TV shows do we have in this data set? And this is going to be a pretty important piece of information if we only want to look at movies, for example. So while this is executing, it is a 7 million row data set. It will take a few seconds to execute. I will allow myself a small drink of water. And if you have more questions, feel free to ask. So Kvikende, are you based in Norway then, if I understand correctly? So we see from this query that we have a lot more than just movies in this data set. And this is actually very cool. There's even video games in this data set, which I had no idea IMDB actually collected. So some weird audio stuff here. 1 second. Don't know what that was. So there's a lot more than just movies. Obviously, movies is a huge bulk of it. It's, 560,000 entries. But the majority of this data set is actually individual TV episodes, which is crazy. So we could do a lot of analysis based on TV episodes as well. Personally, not so interesting for me. I do like to watch TV, but I don't know if I would really want to do an analysis about episodes or TV series. But it could also be interesting for some time. If you'd like to see that, drop it in the suggestion box. Maybe other people would like to see something like that as well. There's also like some weird, I don't know, I would say like odd entries here with these audiobook and episode and radio series. I think maybe those are just like test entries or debug entries for the data set, for them to say, hey, we might do this in the future. This is data you might expect to see here. But we know that we're probably only going to want to be looking at movie today. So something I like to do is basically just say movie rows. $560,000. So Kvikende, yeah, I see you are a fellow Nordic from the description. To some extent. I mean, Northern Hemisphere, I would say. I've been to Norway and most of the Scandinavian countries as well. Quite fascinated by by those places, especially because of the cold. I mean, as I am Swiss Canadian, I basically live for the cold. I mean, this time of year for me is glorious. Sitting in shorts most of the time, while a lot of people complain that it's cold outside. But you know that's how it is. So I like to just sort of make notes about the stuff that we found. And for example, this 2115, the max start year, we're going to call that a single outlier, because it is a one-off of someone who's obviously put something in there for 2115. But yeah, so this title type is a pretty important field for us, and I'm glad that we checked how many movies we're actually going to be looking at. So we are going to be able to look at about 500,000 records. So that's great. And so we'll skip over these titles because, yeah, like I said, I don't have natural language processing skills or even the linguistical skills to figure out, I don't know, how many movies start with N and all this kind of stuff. I don't think that's super interesting either. Of course, it would be funny to figure out that the shorter the title, the better your movie performs. So we could do, I don't know, some stuff about like title length, for example. I don't know, what's this length of title? Is it not primary title? Sorry, I just have to open this again. Primary title. So this is the length. And now we can sort of figure out how many titles with what length appear in this data set. We would probably want to limit this. Actually, I'm just going to stop that. We would probably want to limit this to equals. We want to limit to just the movies, because I think otherwise it's not a super great analysis. So we have 138 titles that are only one letter, which is interesting because, well, there's only 26 letters of the alphabet in English at least, so maybe some of these movies are like numbers, obviously single-digit numbers, or even, I don't know, other characters, foreign characters. But we can see there's like kind of a sort of sweet spot around 13 to 16. Of course, we could like lay this with the ratings data later and figure it out. Longest movie is 242 characters, which seems very long. But yeah, this is the kind of stuff that we're able to do. It's not super interesting yet, but it's something that we could do. Looks kind of Gaussian. Yeah, a little bit actually. So that's just one option. I would like to personally, before we go on, look at the is adult column and the runtime minutes. And I think we'll get into the genres later, because that requires a little bit more work. But I don't think every movie has a genre for it. There's probably a lot of nulls in here as well. And that's something that we can figure out too. But that's something we can do a little bit afterwards. First thing is this is adult flag. Basically, there's only two values, 0 and 1. At least that's what they described in the data set. Let's see if that's actually true. Let's see if there's a third value. So it might be that, I don't know, there's a null value for the table. So the field is not 0 or 1. Because I've actually imported it as a text. So here on the left, you can see I've put a text. So Kirkende says, we had a lot of fun analyzing the adult movies in class, as in the titles, etc. Oh yes, I can imagine. In order to not get banned on Twitch, I'll probably refrain from doing too much with the adult titles. I mean, I'm not going to put it as a filter like don't show them or something like that, because I'm not showing any pornographic content, but depending what words appear, I think I should be a little bit careful about that. So I'm happy to see that there's only 2 distinct values for this data set, because yeah, I would have been a bit upset if there was a null value in here when they said that there shouldn't be. So so the second last thing is the runtime. So if I just put runtime in here, runtime minutes, then I'm going to get everything grouped together. But of course, there's a crap ton of runtime values, everything from 1 to who knows how long. And that might be a little bit tricky to, I don't know, might be a little bit tricky to visualize as well, just for us to understand what kind of data is there. Kukende says one of the producers with the most films produced was an adult one. That doesn't actually surprise me so much. They do produce a lot of content, but it will be very interesting seeing as well this director's angle as well. Something I definitely want to look into as well. So you see here the runtime in minutes, it's just all over the place. So something like here with the runtime, I would actually want to do something with a case when. And I'm going to say if the runtime minutes is, I don't know, is this weird \n they've been using? Oh, that's the wrong one. Then I'm going to call this null, so the actual null. That's the first thing I want to check. Then I want to do when runtime minutes greater than 0, then long, or I don't know, not 0. It's obviously not long, it's just greater than 0. And else I'm going to use the time from runtime minutes. And I'm going to end this as runtime min group. The reason I'm doing it this way is I'm taking basically all of these individual values and I'm plugging them into this not 0. And I have the nulls here, and so if anything else comes up, if I have more than 3 values, then I have a problem. So one thing I need to do is I need to actually convert this to an integer, because the field itself is text. That's my mistake for importing it that way. But, you know, I'm lazy when I import data sometimes. It's just the way it is. So it reminds me to hydrate when I run my queries, because they do take a few seconds to run on this kind of data set. It's actually the biggest data set we've had on stream until now, 7 million. I can't go too much bigger on my local machine either. I know the maximum is somewhere around 14, 15 million. That's when things started to really crash. So this is very good that we only have 3 values. There's 10 titles with 0 runtime, which is probably a mistake. I mean, under 1 minute basically, and then they rounded down perhaps, but yeah, like a 12-second title basically. One of these like Cannes short films or something maybe. Not 0, so a large amount of titles, 2 million. But there are 5 million titles without runtimes. And this is important if we were to only look at movies, for example. This is important because if we wanted to do a runtime analysis, we have to already assume that out of our movie data set, around 40%, so 200,000 here, 40% don't have runtime. So whatever kind of, how would you say, whatever kind of conclusions we come to only apply to a subset of our data, 60%. And that may be, for our purposes, statistically relevant. It may be enough. But for someone doing a more detailed analysis or something a lot more important, like taking a decision afterwards based on that, it might not be enough certainty. It's a little bit the equivalent of having a group of people, let's say 10, and then let's say I only want to ask people who qualify because they are wearing a necklace. So if only 6 of the people are wearing a necklace, then only those 6 people's opinion will count, and the other 4 people's opinion won't. And then may be okay, because if I'm asking about, I don't know, is it comfortable for them to wear jewelry, that's fine. But if it's something like this, where I'm looking at runtimes, where fundamentally movies should have a runtime, it means that I don't have runtime data for 40%. Yeah. If we want to know exactly what percentage this is, we can even do basic math with SQL, which is super fun, let's be honest. We have to make one of these a float, so we get a detailed answer. So yeah, it's almost 42%. Yeah, 42% has that data. I think that's right. So 208 over 3. Oh, sorry, yeah, we're missing 40%, not 60%. Oh, thank you. You did well estimating that percentage. I do look at like numbers a lot, so it kind of makes sense that I'm okay estimating percentages sometime. But I've been using this app to do some mental exercises since about 2 or 3 weeks now. And the math one, there's one math exercise that has you compare percentages with pie charts, kind of like donuts, to say like which ones are the same, like 2/6 is the same as 1/3 or something like that, and I'm terrible at that. So yeah, it shows that even if you do a lot with numbers, you can still be terrible at math, which is why statistics also kind of terrifies me a little bit. Like data science stuff, I understand that kind of stuff really well, but it still really terrifies me working out I don't know, like Bayesian statistics for the significance of experiments or something like that. That still is really, really hard for me to grasp sometimes. And that's something I'm working on this year. And hopefully maybe towards the end of the year, I would be able to do something a little bit in that direction as well. Maybe run an experiment online and show like which one performed better and why it's significant or not significant, something like that. Could also be cool. So coming back to this data set, we've spent a little bit of time here, significant amount of time, I would say, looking at the quality of the data of this table. And that's something I would repeat with each of these tables in a normal scenario, but seeing as the stream is like maybe 2.5 hours, I'm not going to waste more time of the stream doing that. I've actually spent a lot of time doing that prior to the stream, and I can say comfortably that I'm very happy with the quality of the data that IMDB has provided. For free, I might add, but yeah, I'm very happy with what they've provided. So we don't need to do this kind of analysis for all of the tables. For this other table, title crew, or for the ratings, we don't need to go into so much detail about that. One thing we do need to do, however, which I have not done yet, so I'm going to be just as surprised as you about the result, is about the genre. So the first thing to figure out is, when do we have genres and when do we not have genres? So again, we can probably just exclude this one. And instead of an else here, we're going to say when genres length, let's do the length. I think that's the easiest one to check. So the length of genres is greater than 0, then we're going to call this filled. and we'll do an else just to see if there's a couple with 0 or something like that. And we're going to call this genres group. Oh, we have a musical change. If you do have some recommendations for musical styles or preferences, do let me know. We can do a lot of cool stuff with this. I'm just playing directly from SoundCloud via their API. So if you do have some recommendations, feel free to let me know. I'd like to find a longer track like this. No, we need to, this is better. I like to find longer tracks so that I don't have too much talking during my stream and not too much switcheroo. So what did we, yeah, so genres, we didn't execute this. Probably should have executed it while I was fiddling around with the music. Sorry, I took that opportunity to hydrate again. So this is interesting. We have 70,000 out of our original data set of 500 something thousand, 563. So we could do quick maths. 69. Well, we can do a fast version. 70,000. We actually didn't do the math quite correctly before because we actually have to do the sum of both numbers, but 70,000 over 560,000, about 12%. So we have about 12% where we don't have a genre for the movie. So that's okay. I mean, we would be making a statement based on almost 90% of movies. So that's pretty cool. But that's something we need to bear in mind. So for example, genres, 12.5% missing. I'm gonna make a round. I like to make these notes directly in my IDE because then I really don't lose track of them. So yeah, what are we going to do now? We are going to actually try and split the genres out because now we just have the information about each, about whether the genre exists or not in the data set. But actually what I really wanted to figure out was, can we split these into individual columns? And there are a few different ways of doing that, but I'm pretty sure that the easiest way would just be to use split part, because split part is a function that gives us gives us the opportunity to just use a string to figure out like which parts of the input string that we want to split out, and I think that's the right way. I'm just going to do a quick test with that. I believe pick out the desired field from the string, exactly. And so basically the syntax here is basically from what string do we want to take and from what do we want to return. So I think the delimiter is the second one. So we'll try it with genres. Then the delimiter would be comma, and we want to return the first one. So this is genre 1, let's say. I don't know what's going to happen. Oh, look at that. Sweet. So that worked. And there's this n in here. That's the null ones. So we're going to take those out too. I don't know why I can't do a backslash today, so I'm just going to keep pasting it from my clipboard. But yeah, so we have 28 different genres in the first one. we would technically need to do this and determine the maximum number of times we need to do this. And the way that we can do that is by cheating. We can cheat by basically saying IMDB.titleBasics. We can basically count the occurrence of the number of commas in each of these genre fields. And I think probably one of the easiest way to do that would be with a regex function. So Kvikende asks, shouldn't genres technically be a one-to-many table? Yes, it should. If they had provided that as a one-to-many table, I would have loved that. I could have also engineered it that way prior to the stream, but that would make this part of the stream less fun, I think. I think it's important to show also the data manipulation and data change or cleaning side as well, because well, any data set you're going to get in real life is also not clean. It's just the reality that you're going to spend like 80% of your time cleaning stuff up, as you probably know. So yeah, if we have genres here, we could use some kind of I think it's a regex count, extract. I don't remember the name of the function. Probably regex match. I think it's regex match. So if I hover over this, I get a little help window, but unfortunately you don't see it. It's just telling me kind of how the function should be written. So if I find first match for regex, might need to count that. Return number of occurrences of character in string. Something like that. I don't know what people have recommended. The length of the string minus the length of the string where you've replaced those characters with nothing. That seems that seems like one way to do it. I don't know if I like that way. It's a bit hacky, but I suppose we could do that. That would be implicitly the longest comma. So if we had length of genres, that's really very tedious. I'm not sure if I want to do it that way. So these are all the lengths, and then I don't know if that's like a subquery for us now. Could do it as like a subquery, and then we could go and say, okay, this is, oh wow, I even spelled that wrong. That's embarrassing. So lengths is our kind of data set. We have all the lengths. Let's make that distinct. Limit to 10. It will take some time to execute. So we have, very nice, okay. So the lengths, and if we replace in the genres, replace comma with nothing, integer minus text. Oh, we actually need to make one of these an integer. Or maybe both even. This is fun. Oh right, we have to do the length of this. My bad. We don't have the length of that yet, we just replaced it. So the length of the full string minus the length of the string where the commas have been removed. So 2. That means that there's maximum 3 genres. Is that possible? It's possible. Let's take a look here. If I sort, we could even just sort this data set by genre. Let's do like this. So if that's really the case, then let's take the entire genres. So let's say, we don't even need to name this. This is just genres. So we have all of them, and we're gonna order by 1. It does seem like 3 is the max. Okay, that's really cool. That's really good. It makes our job a lot easier. It means that we only need to do this split 3 times. So we do genre 2 and genre 3, and I'm deliberately leaving the genres full one in here so that we can double check our work. So we group by 1, 2, 3, 4, which is 1, 2, 3, 4. This is an aggregation. That's why we don't group by the aggregation. And then when we execute this, we will now have a very large table. This is 1,437 entries. And you see here, this is just an empty string. It's not null. Because we didn't do any check here. We just split it. The way to do this would actually be with a case when is null, then null, else, and then this is the super clean way of doing it, and then end. And then you'll see here these will all become nulls. Oh, that's interesting. Oh, sorry, not null. Is empty string. So because it's an empty string, it doesn't have a genre because it wasn't able to split it. There's a lot of different ways of doing this. You could like count the number of commas first and that kind of stuff. I think this is an easy way to do it. And yeah, the first one would also be null if we didn't have the ones that were already null excluded. So we could do the same thing again here. With the third one, genres 3, then null, else, split part genres 3, genre 3. And you know what, I'm going to do it with the first one, just in case we change something later and we don't have that filter in here with the null genres. And basically now it looks like this. And so, Kvikende, since you asked, we could actually expand this onto the original data set as a one-to-many table. But because we now have each genre split out into a separate column, we can actually do the following. tconst is this ID, and we're going to just take out this. And you see that's why I was doing this here with this case when. If I don't have a genre for my title, then these are going to be null, and that's fine. So this is just going to execute for a while. I should drink something again. So I have to forward the music here a little bit. Sometimes this is going to take a while to execute, but essentially the idea behind this rather than counting, maybe we shouldn't count at all, and then we don't have to worry about it. If we don't count, then what we can do is basically annotate the data set with our columns. And the way that we can do that is by re-importing it onto the existing table. Or we could create a new table called title genres. And then we would have this tconst key that we could add onto the table. So I'm going to export this from DataGrip. Never used case when and the string manipulation part of SQL. I assume the string manipulation and regex isn't technically part of SQL. It is. So SQL query language, I mean, it depends how you define. Sorry, I just have to skip the talking bits here. It depends how you define what you determine to be SQL. I mean, the query language itself only deals with transactions that occur on the database, but I mean, the whole query language itself has functions in it that are, like, for example, math functions like divide by. Technically, divide by isn't from SQL. Of course, it exists just in math, but I mean, that doesn't mean it's not part of SQL, if you know what I mean. But I know what you mean by that it's technically not part of SQL. I mean, the query language of the database, I mean, it's executing it on the database, of course. But yeah, so I'm just going to execute this as an export, which will give me all of the titles with these genres split out into genre 1, genre 2, and genre 3. And you don't see the export window, but I just executed it, and that's why it's running this query. And then eventually it will drop it as a file. You can see here on the bottom how it's executing these rows, and there should be around, well, 7 million rows in the end. And then I can just re-import it as a table later. And that's something I can do between now and the next stream or something. I don't think we're going to need the genres today, but who knows? It's only the first 3 as well, but that's, yeah, not something I think we'll need, let's say. So from a quality point of view, this data set is great. I really like so far what they've done. Everything is very, very understandable and really well labeled and very clean. So the first thing I want to do is answer a really, really simple question, which is how many titles came out in which year? So basically movies, right? When were they released, in what year? And it's just for me to understand, because, you know, I don't analyze movies typically, right? This is like it's a foreign data set for me. So I need to understand the data a bit better, and that's one of the things I want to do, is understand the release years of the movies. So I've exported that. I could actually run this import in the background. You won't be able to see the import window, but let me just run the import here. Where did it drop this file? That's the very good question. Yeah, that's this one here. 1107 errors in import. Lovely. So it's not a great name, let's be honest. So DataGrip is really cool because it provides all these import features. So I'm going to call this title genres. Ba-ba-bum. And that should be relatively simple. So I don't know if you've seen here this table appear on the left, title genres. It's going to spend some time importing here. You can see that here on the bottom of the screen, there's this little orange progress bar telling us how fast it is. So it's going to take a minute or two. So again, coming back to the release dates, I want to understand what the release dates are. of the movies, because I really don't understand. I don't know a lot about movies, so we come back to this filter with the title type. Don't think I'm going to need that for the moment with the order by. And basically what I want to do is basically have start year, I'm going to just call this release year, and then count distinct tconst. I forgot group by. I'm sorry, it happens every time. But if you see me forgetting the group by, you should totally tell me. So, this is where all the movies were released. Now, I don't want to scroll through every single year since 1897, because there's 133 rows here. So I'm going to start basically grouping them or putting them into bounds. And that I'm going to do also with case when. Very useful function. So case when start year is between 1800 and 1900, then old. Alright, we're gonna end. This is the release year. Release year group. So that's the first thing. We are going to need to convert this into a integer, because the start year in the table is a text, and we can only use between with an integer function. So we're just going to do a quick check. Oh, it didn't like that, you see. Invalid input syntax for type integer. We have to take these n's out. Start year not equal to \n. There we go. So there's 22 old titles. I'm just calling it old. Maybe it's not the best name, but yeah. So we're going to copy that and we're going to continue. And I can choose how to make my buckets. I'm going to just choose to make my buckets this way, that anything up to 1980 is going to be old. I mean, I'm born in 87, so I'm using this syntax as old, but in reality maybe it's not. So anything between 1981, or maybe it's not right, 1950 maybe. 1951 and 1960. So I'm going to call this 1950x, I believe. Maybe we should do 1949 because it's inclusive. Then we could do 1950, 1959. And this would be like each decade, right? And I know each decade actually has like official names, like Roaring 20s, etc. So if someone wants to look those up and we want to use those, feel free. But I'm just going to go with sort of classic decades. There's a probably more clever way to do this. Was going to ask if it was exclusive. Quickende, yeah. It's inclusive in between, so we want to be careful when using that. Otherwise we get double counts, which is not a good thing at all. So basically here I just want to have a better idea about when movies come out. What's one thing we maybe expect to see here? Feel free to lay in the chat what you think we are going to see. I have an assumption. My assumption is that the number of movie releases increased over time with each decade in terms of absolute numbers. Whether that's a good or a bad thing, you tell me. but I think that's the case. I do think that the number of releases increased over time. But we don't know for sure until we do it. And that's the fun about data analytics, is we don't know anything until we actually try. Or maybe that's a general life thing, who knows. So 2010 and 2019. So I don't know if these are really called 2010s. I mean, we just sort of closed that. We are going to do a 2020 to 2029 and call this the 2020s, and knowing full well that anyway 2020 is a bit of an outlier, and assuming we can't look into the future yet really, we're just going to call the rest, we're going to call them the future. And now we can actually just sort of run this query and see if I was correct. 20, 30, 40,000, 70,000, yep. So, yeah, the number of releases has increased every decade. Amazing. I mean, I'm obviously the best analyst on the planet because I was able to figure this out before even running this query. I'm being very ironic. This is something I assume to be true, and it's good that we just validate it. I don't think... Wow, I need to forward the music again, sorry. That was a doubling, says QuickVende. Yeah. I mean, depending on what period you're looking at, but yeah, here it's really between 70 and the 90s, it was pretty slow pace, you're right. Assuming that we wanted to look at this in a bit of a cooler way, we could actually do that. And that's worth showing you guys because I really like using visual methods, but unfortunately, I mean, DataGrip is just not, it's not a visual tool, right? So I actually have a way to do that. Give me 1 second here. So this is that. I actually have something set up that will allow us to do exactly that. And basically what this is Metabase. It is also running within this Docker container. So that's hence the address, localhost, just on my machine. It's open source, not doing like any advertising for them, but basically just saying this is one way of doing it. It's a BI tool like anything else. It allows you to sort of attach databases to it. And one thing I've done is attached my Postgres database. And what we can do now is actually, we can write SQL directly in here. So I've been doing it in DataGrip, mostly because Metabase doesn't have a dark mode. No, that's not the real reason. Mostly because I like using DataGrip because all the functions are there. Whereas this is just really raw. Yeah, like you don't see the schemas, you don't see... Yeah, it's really completely raw. But if you do have a query, you can run it directly. And so if I actually copy my query from before into here, I actually get the same result, I would hope. Oh, multiple result sets. That's not cool. I don't know, maybe it was doing something weird. Should work. There we go. So we actually get the same result as before. So the old ones and the old ones. So prior to 1950s, there's still 70,000 titles, which is pretty impressive, actually. But that includes multiple decades, right? Even centuries, rather. No, sorry, back to 1900. So, and technically we should improve this because it should be 1899 and 1900. Sorry, there's a lot of cheering here. I'm actually going to just skip to the next track because I don't want that. All these festivals and stuff, they have like these live tracks, and they are a bit annoying. So I'm actually going to switch completely to a different so Kvikende, you said that's when like Charlie Chaplin was big. Yeah, I mean, it's a lot of the time. Yeah, it's a long time ago. Oh, this is really annoying. Give me one sec to fix this. This is annoying. Sometimes the SoundCloud API that I'm using bugs out a bit, and that's a bit annoying. Oh dear. So it's actually, yeah, it's like terminated this entire thing. Give me 1 second. Fix this. Oh dear. This happens sometimes. It's like a web app, so it sometimes doesn't cooperate because it's really small and it's maintained by some guy privately, and it stops working sometimes. So while that's booting up again, which it may or may not return, yeah, so we can run this in Metabase directly, which is really cool. And we get this result. And the difference between Metabase and this is that between DataGrip and this, sorry, is that I'm able to then visualize this, for example, like this, which is super cool. So Kvikende asks, are you also into tools like Pandas and R? That is the next step for me. I do have some experience in R, and can write a little bit of Python, for example. But that is the next step for me this year in particular, to move more into into statistics. There's a few topics that I want to tackle. For example, forecasting, time series forecasting, something I'm very interested in doing. This is coming from a more business context as well. Do you have experience in those, in things like Pandas and R? I think there's a lot of potential with those kinds of tools to do also really detailed plotting. But I also like to show here how something very simple is very easy to achieve as well. So if someone wanted to do the exact same thing that you see here, they would be able to set all of this up in an hour if they understand how technology works in a sort of average way. They basically download Docker, they initialize a Postgres container with the Postgres database, they configure the access settings, they download the images for Metabase, they're also freely available for Docker, and then you connect the two, and then you're up and running. And I think making that accessible to people is a big step in improving what we call data literacy. So that's basically people's ability to work with data and analyze it properly. I feel, I mean, it's a personal opinion, but tools generally are not as important as skills, because you can learn tools, but learning skills is a lot harder. And also sort of like the right way of thinking and stuff like that. So so this is this release year, and we can see the sort of visualization of how many were released. And this doubling that you were talking about, Kvikende, you can see here, this doubling occurring between the 2000s and 2010s. Will we see this at the end of the 2020s? Who knows? That remains to be seen. 2020 is definitely an outlier itself. There's a lot planned for this year that wasn't released, or last year rather, that wasn't released. But yeah, I think we can go further and do more interesting things than just based on release year. But that was just something I wanted to do on a basic level, so that I could have some basic understanding of when movies are released. That's just for my understanding of the dataset. So I'll leave that there for the moment. It's not something we need to delete or something like that. But I'm going to just create a new query window so that we can do the next thing I want to do, which is a little bit more complicated. I want to join these sets together, these tables. The reason being, let me just get this IMDB title basics. The reason being that I only have title information in this table, and I have title, type, primary title, the adult flag, etc. But I don't have ratings. And one of the things I need to have for some more analysis about the films or the movies is the ratings. So I will keep my filters. I'm cheating, but yeah, I can cheat because it's my own IDE. I'm cheating by copying that from there to there. But basically I want to join the ratings. And if you're not familiar with joins, it basically means putting two tables together. So I'm going to boot back up my music application here. Let me see if this works. There we go. So do let me know if that's too loud or too quiet as well. So Quiquende says, did some data analysis on a huge data set for the border gateway protocol for the university. I don't know too much about data analysis, but they wanted the computer engineer when the full data set was larger than available memory, and the analysis took longer than data was generated. Wow. Yeah, I was working with a data set recently that was around 280 million rows. And of course, locally, I wasn't able to work with it. Locally, I can do about 15, maybe, and then things started to crash. So I was doing it in BigQuery, in Google's BigQuery. And yeah, the analysis, we spent a lot of time engineering that data set and making it work for us. And the analysis definitely took less time than the engineering part. But you're saying the analysis took longer than the data generated in the first place, is that right? Do I understand that correctly? So this has a lot of words in the music. I think I'd prefer something else without so many words in it. We can maybe go back to something more trancey. There we go. So, why do I want to join? I want to join the ratings onto the titles so that I have the ratings in the same data set that I'm working with. And joining basically means combining data together into the same, I would call it data frame, so that you can work with that data at the same time. And so we're using a left join. A left join essentially means that this table, this title basics, is our master. And this table we're joining onto it if the keys match. However, all the rows will be included. from the right table, so the ratings table, but those keys that don't match will be discarded. Because, well, let's do it. So I have tra.tconst, that's this identifier, is equal to the tba.tconst. So if there was, let's assume, select star from IMDB dot title ratings. So we'll just do a quick count here. So I have 11 million rows. If there was some of these 11 million rows that didn't match into title basics, then they would be discarded. And you know from our previous analysis that we only have 7 million rows here. It means that we have multiple ratings per title, perhaps? So Quikende said the code I was given spent 30 minutes to analyze 10 minutes worth of data. And the new data is continuously generated, so the analysis would never catch up. Yes, I mean, IMDb's dataset, for example, is the same. This is just a snapshot, right? We're just looking at a point in time. That's where sort of like real time and streaming and stuff like that come in, where people find a lot of value in having something that's continuously updated and shows, for example, I don't know, if you update a data set every 10 minutes and you show the delta to the previous 10 minutes, then that can be something also that's very interesting. So let me just jump to this title ratings. Do we have more than one rating per title? We don't. You see, we have this tconst. It's the same number of rows. It means we have one title per row, and that there's only each title occurring once. But we have 11 million ratings. That's more than the titles table. There's probably a reason for that. I'm not sure what the reason is, but it could be that they're not exposing the titles in the title basics, for example, because the title basics table is a kind of summary table. So again, this has like 7.5 million, and there is a raw table that they have, and the raw table has each title's variation in it. So for example, different language variants, I don't know, director's cuts, yeah, all kinds of that stuff. But the title basics is like basically one unique row per title, and the other table has obviously per title all the variations of it. And I think that's why the ratings is larger than this one. But there's no explanation for that in the dataset. That's just my gut feeling. It doesn't really matter though, because we're using a left join. So if we do a count here, we will have, if I can do that properly, we will only have the ones that matched onto the title basics. So we had our previous number of movies here, 563, and then we've now filtered as well for the ones that have a start year. So we already engineered a kind of filter for that, so that's why we have less titles. And now basically we can start to do something with the ratings and figure out what kind of movies are rated in what way. And this is one of the things I was excited about. So for example, if we wanted to see the previous analysis that we did with these years, maybe we want to figure out what the average rating per year was. We could do that. Maybe as movies get older, they get better. That's maybe a hypothesis. So basically, anything that's We don't even need to necessarily include movies from the future, but we'll just leave them in there for now. So we obviously have the number of titles. Vikende says, or they had lower standards. Well, let's not forget that the ratings themselves are always current. So these ratings that are in this table are an average of all time. Unfortunately, we don't have a time series data set of the ratings where we can actually look back and see if the ratings were more generous for different types of movies. That would actually be pretty advanced to do that in SQL. That's probably where I would want to have something more like R at my fingertips to do that. But what my hypothesis is that over time, movies that are released more recently tend to have higher ratings. My basic assumption is that movie making got better in terms of audience understanding, like what people want to see. But of course, as you say, it could be that people just lowered their standards. Who knows? But it could also be that people watching older movies are, of course, a younger audience or an older audience, so they appreciate it more or they appreciate it less. And there's a lot of sort of implicit factors in there. That would have been so cool to see which movies were rated pretty bad and when were released and is now highly rated. Yeah, absolutely. But I did say earlier today that if IMDb actually had the time series data set of the ratings, I think it would kind of cannibalize their product a little bit, because people go to that site for that part of the product, for the ratings, and they would be giving away kind of too much for free in a way. I mean, I understand it's a free website, but they make money somehow, and I'm actually not sure what their revenue model is. But yeah, let's see if movies got better over time. So one thing I actually like to do is write a question here. We can't ask the question, did movies get better with age? Because we don't know when they are when the ratings are being given. These are just ratings over time as one number. So I think they have a premium service for extra info. Ah, yeah, that's true. I think there's like a subscription you can get to have some extra stuff. Maybe in that subscription you would have access to the time series data, maybe. But yeah, for me, this is going to be really interesting to see if this is the case. So we don't necessarily care about the number of titles. We had that before. We actually want to have the TRA.average rating. Now we have to be careful because the average rating for each of these titles will not be averaged yet. So basically for these groupings, we won't have an average rating. We'll just have each value for each title. So we need to actually use some kind of function to do that. Oh yeah, it's actually called just average. And this is the average rating. Oh, this is really exciting. I don't know if it's going to be... Let's find out. We should maybe order it by generation, just to be fair. All right, here we go. Yep, I forgot the group by. Let's be honest, no one's really surprised. All right, here we go. Okay, that's pretty interesting. What do we see here? The rating margin is really narrow. Really, really narrow. This is just the average. But the margin is pretty narrow. Old movies, so these were movies prior to 1900, have a 4.52 rating. We could say that this is definitely a technological issue to some extent. I mean, maybe people just don't understand that those movies had a different technological basis, but yeah, I mean, this is pretty interesting because actually if we look at it from a chronological point of view, so if we discard, let's say, before 1950, and just look at 1950s onwards, we can actually see that there's a bit of a dip. So if we were to visualize it, it would be sort of a tiny dip, but it would be a dip. Let's just plug it quickly into Metabase to just visualize the dip there. This is why Metabase is actually quite useful for that. So there is this dip between sort of 1970s and 1990s, and then apparently movies have gotten better. But I mean, the spread is pretty small. What we could do is on the y-axis, we could make it logarithmically scaled, and then we would actually see the difference a little better. But it's still not helping so much because it's such a small difference. But generally speaking, movies have gotten better since the 90s, for example. At least according to all the ratings on IMDB. Whether that's representative or not is a whole nother question, right? That's something that we can't really determine. A line chart would be a little bit easier to see. So this is just the linear and this is the logarithmic one. So basically, I don't actually like the sort. How can I sort it the other way? Just do it the other way. So the old stuff is not so important. We'll just null everything else. Empty. Okay. Else null. I normally don't need to do else null, but can just null everything else. Anyway. So this is pretty funny. I mean, maybe, sort of. I mean, here it looks very dramatic because it's logarithmic. I mean, in reality, it's pretty marginal. Does it mean that people's tastes changed or even habits? Who knows? I mean, it's a bit hard to say. Pretty funny. That's at least one thing I wanted to look at. I don't know, the conclusion of that is, did movies get better over time? Technically, yes, at least since the 1970s. But again, these ratings are being given aggregately. Now comes the fun part. So, what kind of genres do we think have the best ratings? Let's go to a new query window. This is just something I like to do, is I like to keep my queries separate so that I can save them later and come back to them. And I'll save these and name them and stuff like that, so. Okay, so Kvikende's guess is adult ratings are good. You might have some secret information there that I don't have. But yeah, I mean, I would love to know which genres perform the best. It may be that the number of votes is very important. That's something that we didn't look at. Oh, that's something we should actually do very briefly. Is the number of votes. We should actually kind of just see how many votes we're dealing with for each decade, because yeah, I mean, the number of votes is pretty small for the 1970s, for example, compared to the 2000s. I mean, this is a 3 million? 30 million? 30 million compared to something like 260 million. So I mean, they're big numbers, right? It's at some point significance is already there. I mean, with 30 million votes, it's already very significant, yes, but you know, there's more users on the platform voting for more recent movies, logically speaking, but I mean, IMDb also only exists since a certain amount of time. But let's see, maybe there's something to be said about genres. So, question: which genres have the best ratings? And what I like in particular about this is that when I run a query like this, for example, the comment normally comes up as the first line. It didn't do it here for some reason, but it normally comes up as the name of the result, which is also kind of cool. Order by 2. So this is just the raw genres, and you see here there's no rating. So that's a bit of an issue. We need to also exclude and average rating is not null. So this is the ones where we have ratings. So Viquende's guess was adult, purely based on these combinations. So 9.4 is comedy, documentary, fantasy. Now you have to remember that these are combined genres in a way. So I don't see how a movie can be a documentary, comedy, and fantasy, but I guess it's possible. It just sort of doesn't click in my head what kind of movie that would be. But we now have a different data set where we have the genres, and this is what we worked on earlier today, is that we actually have each subgenre for each title. So we could actually split this off a little bit, and for that we will need to join this data set also onto this data frame that we've been working with. Fantasy documentary, a documentary about elves in Lord of the Rings. Well, it would also have to be comedy, so it would have to be a funny documentary about elves in Lord of the Rings. I mean, it could be like a director's cut, or like what's it called? Director's commentary version of a fantasy documentary. I don't see how documentary and fantasy go together. That's the only thing. So this is title genres. We have the same key that we've been using, tconst. Oops, tconst. And now instead of taking just the genres, we're just going to take this first one. Oopsie. We're just going to take this first genre just to see. Ah, very interesting. So documentary gets the highest average rating. Actually by a not insignificant margin. We should also exclude and genre 1, or let's say genre in general. I think it's in tba.genres, yeah, is not equal to n. So where we have the genre in the first place, just to clean that up a little bit. So this is pretty funny. I mean, there's 28 genres here, so it's worth plugging this quickly into Metabase just to have a visual of this. Doing some science, okay. So, what kind of visual? I think I'd like to have a bar chart. Okay. One thing I want to add here is the number of votes. Because I would be concerned that we might not have enough votes for some genres. Oopla. Does not exist. Really? Okay, it's tra.numvotes. This is the problem with Metabase, is that it doesn't give me so many hints about what's actually wrong. Here we go. Now I could actually do this combo where average rating. Okay, so we can see the line, which is not a it's not a great line. I'm not so familiar with the display stuff, but can I actually change the thickness? Here we go. So the sum of the votes, I'm actually going to make it a little bit thick here. Linear interpolated, blah blah blah. Can't really make it thicker, but that's fine. So what we see is that action has the most votes. Is that because there's the most amount of titles in action? This is something that we should probably do, because the number of votes could skew this rating, right? Because documentary only has 7 million votes, which is not that much. So how would we go about figuring out this kind of, I don't know what we would call it, participation rate, I think we would call it. We go back to DataGrip just for sanity purposes. I want to keep my query in here, and then just do the rest in Metabase if I want to. But so this is the sum of the votes, fine. So I have it for this first genre, but I need to figure out how many titles are in this genre. So I make a sum, a count, distinct of tba.tconst, and this is number of titles. And I need to do, so I could either make this a common table expression, or I could do the kind of lazy man's version and just do a nested select. Something like that, where I just call this something and just use this information within here and basically say genre 1, or I could output everything and just additionally do an aggregate of these two things. I could try to do this in one line, but it's pretty messy to do a sum over a count distinct. It might not like that. So we're just going to do the easy way, put out everything, and then do the sum of the votes divided by the number of titles. Okay, so we have like a participation rate. So if there's a lot of action movies and there's a lot of votes, that's fine. We're going to make this a float, and we're going to call this the party. Let's call it party rate. I don't want to write the whole thing out. What do we get from this? All right, so we have a party rate. Very interesting. Very, very, very interesting. Yeah. I think we should do it the other way around. I think we should divide the number of titles by the votes. Or what do you think? Kvikende, if you're still watching, anyone else who feels like contributing, what do you guys think is more significant to look at? Because right now we're looking at the number of votes based on the number of titles. So there's 26 votes for 2 titles, which of course equals 13 votes per title. And this is like 6,000 votes per title. Biography, there's like 200 votes per title. I don't know, I mean, if I visualize this in Metabase, let's see what I get here. let's see. So I want to made a boo-boo. So genre 1, let's say the average rating and the party rate. Maybe the other way around makes sense. Yeah. Although you can't really see it, it is better the other way around. So as the rating drops, there's no discernible pattern for this party rate. Basically the number of votes per title. But we can see like some of these have crazy amount of participations. There's like 32 titles with 500,000 votes, which is nuts. So these are definite outliers. The action one definitely has high participation, but so does this stuff in here. We should definitely do this with the second genre. So this was the first one. Let's do this with genre 2 and see if this looks any different. I don't know what the significance is between genre 1, 2, and 3. I just know that there's like different ones. I don't need number of titles. I just need party rate. So again,
Stay up to date with Ali and www.aliandfeeder.com.
sorry about the talking here and the music. Again, this like to me doesn't have any discernible pattern. Like it's not like the lower the rating, the lower the participation of number of votes in relation to the number of titles. Are the titles listed in some order? No, I mean, you mean on the site itself? No, I mean, you mean in our analysis? I mean, I'm not sure what the, I think probably it's a classification of what's the most accurate title for it is genre 1, and like the next accurate and then the next accurate. And I mean, in a lot of cases in genre 3 it was empty, right? We didn't even have information about that. So we are looking at where there's even a rating in the first place. I mean, if a film, Quickfende says, if I mean a film has a genre documentary, comedy, or comedy, documentary, are they different? So I believe that then the categorization is then it's, in the case of documentary, comedy, it's primarily a documentary, but also a comedy, and then vice versa in the other case. I don't think it's arbitrary. I think it's chosen for a reason. So like genre 3, sci-fi, has a lot of ratings, and that might come back to like the sum of the votes, right? This 80 million votes per 2,500 titles. This maybe comes down to a lot of action titles also having sci-fi as a third genre. But the relationship between these three, I haven't looked. Funnily enough, there's a lot of ratings for titles that don't have a third genre. So this empty here. So we can't really say. It's a bit tricky to say. There's no discernible pattern in terms of, well, if you vote more, you'll have a better result or something like that, which is also nice, I guess. But we did learn that basically documentaries are the highest rated. So sum is not important, number of titles is not important. So we have this party rate. Film noir, for whatever reason, has a lot of people voting. Now I'm curious what combination of genres are the least common. Well, we could easily just show in the table the least common combinations. We could definitely do that. IMDb.title. basics. Genres, count, distinct. I think film noir is a very rare type of genre. I think so too. I mean, the purely number of titles is going to be small, right? So if we then order by 2 descending, then we get, oh man, see? Group by, it's just the killer. Order by 2 ascending, and then we get the smallest one on top. You ask and ye shall receive, Kwikende. If you ask, we shall find out. This is a collaborative session after all. This will take a few seconds. I mean, I just sort of say what the data gives, right? So obviously the ones, maybe we should discard those, obviously the singles, but we could maybe search, because we're interested in the film noir stuff. Rare genres like... If we do it like this, then it could appear anywhere. Yeah, there's really not a lot of them. And fundamentally, they're classified primarily as crime or drama. That's what I love about data, it raises new questions. Yes, I agree with you 100% that looking at data raises new questions, which then you spend more time answering, which then you raise new questions with, and it's sort of an endless cycle. But like, yeah, this film noir case is kind of funny because it seems like they're not even classified primarily as film noir. But the titles that do have that classification, so there's a couple hundred here, about 700, they do seem to have a lot of votes, which is quite funny. Could be a case of botting or something like that as well. Definitely possible. But yeah, so which genres has the Becky rating? Documentaries. If we go back to like this purely rating case, we have basically documentaries having the best rating, and then music, which is, I mean, there's not a big gap, but the gap is there. I mean, what's funny is that I would actually classify this and like these top 3 or even the top 4, I would almost classify as having a kind of realistic how would I call this? Like, they're non-fiction to some extent, I guess, but they're kind of like things about real things. Kukende says, could also be that because there are so few, they stand out as unique, and that's often something people appreciate. This is also true, which is why I want to use the number of titles as a filter, because I actually want to do it where there's at least 1,000, for example. So I don't care if there's like under 1,000 of them, if I was being just silly. And I would say here, where number of titles greater than 1,000. So I discard like all these small little sectors, blah, blah, blah. And then there's basically 17. And honestly, the spread is pretty big. We go from a 7.199 in documentary all the way down to 4.83 in horror. And you know what? This shocks me that horror is on the bottom, and that's something that we wanted to dive into, and I think that's a great chance to do that on the stream as the last thing we can do today, because we have been on for almost just over 2 hours. And I did tell I did say at the beginning of my stream, if you weren't there, that my girlfriend is really into horror movies, and so I said that I would do a part of the stream on horror movies, and this is a great segue to that. It's maybe not the best segue that I could have imagined, that the average rating for horror movies is the lowest on IMDb, but I have a hypothesis for that, and I would say it's going to be very difficult to test that hypothesis, so I'll just tell you what it is. I think that horror movies, if they're done badly, are really bad, and that's why they get such low ratings. That's just my personal opinion. I don't think it's something we're going to be able to test, but I wanted to do some stuff about just horror movies, so let's dive in. Sad Salami Rose says she has like a sad face, so I assume that she really likes horror movies. Kivkende, can you also answer if old horror movies are better or worse than newer ones? And that is, it's so great that you say that, because that's the first thing I was going to do, is combine the two things that we've been looking at, which is basically the release year and the genre of horror movies. So let's open up our trusty new tab. And let's raise the question, are older horror movies better than new ones? That is the question. So let's take what we have. We definitely have some good stuff here. Alright, so we have a release year, we have ratings, we have some of the votes. We also did a nice little nested select here. So number of titles. Oh yeah, I forgot the number of titles. We should add that. I could rewrite the code, but it's just easier to copy paste it, you know? So we have a party rate, and now we can start to filter and genre. So we're gonna do it this way, that I'm gonna take the whole genres and I'm gonna do it with if horror is in there anywhere. We can look afterwards about the placement, because that would be something funny. It would be funny to see if the placement plays a role. So I made this small so that we can all see it together. Here we go. So, okay, let's look chronologically. So the old movies, to just remind ourselves about that, 1900s. You have a suspicion, Kukende has a suspicion, that comedy horror might be bad. That could be. That could be. We're definitely going to look at the combinations of those genres, because I think there's something in there. So the old stuff, we're just going to forget about that for now. 1950s onwards. This is kind of interesting. Basically, are older horror movies better than new ones? It's a mixed bag, because there's a lot of new ones. I mean, there's a lot more. There's 11,000 titles in the 2010s compared to only 4,000 in the 2000s. And the vote rate is also much lower. 2020 would have a lot of horror documentary. Yeah, probably. Shocking that there's already 2,000 in here. If we scale that up for 1 year out of 10, then there should be almost double. 1970 was the year when horror started booming. Okay, so Satsalami Rose knows a little bit about horror, I assume. If she says that. I assume it's a she. Actually, I'm not sure about that. Sorry, Salami. Could also be a guy with Salami Rose. That's true. And Kwikende as well. I also sort of assumed your gender, which is not really good, actually. But so 70s started to get booming in terms of number of titles. we don't really see the number of titles, at least on IMDb, right? This is not maybe definitive, but the 2000s really a lot of titles. But we can see that the vote rate tended to go up. But here is where it really tanked. I mean, basically the participation rate halved because the number of titles exploded. So we have way less votes per title than we normally would have. There was still a lot of votes. They made almost almost 10 million more votes, so that's about 50% more. But that's not enough when you have like almost a tripling of the actual number of titles. So the mixed answer is old ones are the best. Old ones, like basically between 1900 and 1949, are the best. But generally speaking, are older horror movies better than new ones? We can say generally speaking, yes, we can. Now I don't know if that angers either of you, Kvikende or Satsalami Rose, but I find that pretty funny because technologically speaking, the poor ones should have been earlier. But we also know that filmmaking abilities, so basically the technology becoming more accessible, happened around this time. So more and more people were able to make budget movies because, well, Paranormal Activity and stuff like that, right? They just became very easy to make. So it would be worth looking at the split of the individual genres. So this is the classification of the release years. Let's look a little bit more into the subgenres. So I don't care about the individual votes anymore. So I want to take the release year group, participation rate, average rating. Okay, that would be just those three. Okay. I don't care about old stuff, but that's fine. We'll just leave it in there for now. I wonder. So about these genres, let's join the subgenres on here. I'll just put this away for now. We're working on the query. So the subgenres are also in here. I mean, basically the genres split out as we did before. Now we can start to look at, we have to include them here. So what do we call this? TGE dot genre 1, genre 2, and genre 3. So, Salami Rose, do you know anything about horror that would make our analysis a little bit easier as well? In terms of like, are there combinations of genres that maybe you would say perform better? Because I know nothing about horror movies, basically. I'm even a little bit afraid to watch horror movies. So we have to do some more groupings here. Group by 1, 2, 3, 4. That's 1, 2, 3, 4. That should be good. So Kvikende says I'm the biggest wimp, so I can't watch horror. Yeah, I mean, when my girlfriend watches horror movies, she watches them on her own. I really can't watch it with her. It's just, it's too difficult. So we're going to include genre 1 and genre 2 and genre 3 in this table. But you'll see it's going to be a little bit complication. I'm covering my eyes and ears. So Sad Salami Rose says, hard to tell, paranormal ones seem to be popular. Okay, this is interesting. So we have a table. Unfortunately, this table is going to be very large, 756. So one thing we can do to make this a bit easier is we can order our result by column 4. 1, 2, 3, 4, 5, sorry. Just to see about the ratings. Oh, look at that. We have to take the ratings that are null out. This might influence as well how many ratings we have. Okay. So purely based on this, wow, Kvikende, I think your suspicion was the opposite. I think you wrote that you have a suspicion that comedy horror might be bad. Zombie monster might be popular, paranormal one might be popular, says Salami Rose. So this is pretty interesting. 2020s movies that are comedy, documentary horror have the highest rating. I have a suspicion that Paranormal Activity is maybe skewing the result of those, because the spread is huge. I mean, we're talking 8.2 to 8.7. That's a massive difference. So generally speaking, it's very hard to find patterns like this, purely based on visuals. But like documentary and horror are coming up quite often. We can see that here. Documentary comes up very often. So we could start to sort of do some combos to see if some combinations have generally speaking higher ratings. The participation rate, I can tell you already, is the difference here is just huge. Documentary horror might actually be pretty popular because I think people are interested in real life ghost stories and such. Kvikende, I think you're right, because YouTube has like a huge Paranormal Activity, like this is like ghost story stuff. I mean, it's just crazy. So what's funny to me is that a lot of 1960s movies are rated really well, that are documentary drama horror. It's quite interesting. But the party rate is all over the place. I mean, we've got like 20,000 votes per title in these really old titles, because these are, yeah, like there's not that many of them, right? So one thing we could do to make this a bit easier to look at is combine these genres. And so what we do is we remove genre 1, 2, 3. And then we say here in our final query, we just say where. Oh wait, we have to sort by 2. We don't have 5 columns anymore. So we do where genre 1 equals horror. Now we could do this actually a little bit easier. Let's do it a different way. Case when. We could do this with a case when. So when genre 1 equals horror, then horror primary. When genre 2 equals horror, then horror, oh, I forgot the thing here. Horror secondary. And when genre 3 is horror, then horror tertiary. And then else, who knows? Because it shouldn't appear, because we did a filter for horror in the genres, but yeah, who knows what happens. So then we can just end, and we'll call this horror cluster. Group by 1, 2. Oh, we don't. Do we need to group? Yeah, 1, 2, 3. I think we need to group by. Oh no, that's sorry, that's the grouping below. Never mind. Order by 2. Let's see what happens. Let me take out the release here quickly, just to see, just to make it a bit easier first. So, oh yeah, of course. So because we have a case when, we did the poor man's version of the common table expression, and that's why we don't have all the aggregates. So it would make sense now to say we can just do more nesting for now, but I would probably want to do this properly at some point. So we'll call this T1 and we'll call this T2. It's just a bit messy this way. I prefer common table expressions where we have each one properly nested out and everything, but we want to do everything except the release here for the moment, and we want to have, in addition, we want to have, actually we can just write this out again, why not? Then we don't need to worry about it. So we want to have the horror cluster. Be careful how I pronounce that. Twitch might like get angry or something. We want the average rating, so we have to average the average rating, because again we're doing a aggregation of more values, right? Because we've taken a case when statement to individual titles that have been grouped, but they now have to be grouped again. So we have to do an average rating again, and then we have to do the think you're fine, just claim its accent, says Kvikende. Thank you. That's reassuring. So we'll do a average party rate. I think that makes sense. This is again this participation rate. We were just lazy and didn't write it all the way. And again we have to put group by 1 because otherwise it's not going to work. Does anyone have any assumptions about what we're going to end up with? There's obviously 3 values. This is very interesting for me. I mean, this is not, honestly, this is not what I expected to see. I expected it to be the exact opposite. But essentially, if I were to summarize this, I would say when a movie is primarily classified as horror, it gets a lower rating than if it's classified primarily as something else. I mean, rather like if horror is the tertiary category. Because we made an assumption before that the order of the genres is the accuracy of classification, right? But this is kind of funny because, I mean, this participation rate is pretty even. I mean, we have like, say, 3,000 votes per title in these 3 categories. So that's kind of weird. I mean, basically, if we were to ask the second question of this data set, you know, does the classification of a movie as horror, or does the order of classification of a movie as horror change its likelihood to be rated lower? And basically, the further, what would we call this? The further horror is not the, further is not the right term for this. Are you going to tell your girlfriend about your findings? Well, I told her that she should watch my stream. I'm not sure if she's watching the stream at the moment, but if she watches the replay, or at least watches the video, then she will find out about what we found out. um, honestly, I mean, it's just data, right? I mean, why would I lie to her? I don't lie to her in any case, so why would I lie to her about data that I found? I mean, I would tell her the truth. I would say that if a horror movie is primarily classified as something else, it's less likely to be good, well rated. Which I think is kind of funny, because then now I could technically pull out movies that are all you have poor taste. IMDB says her favorite genre is bad. Yeah, that's dangerous. That's definitely dangerous territory. I mean, basically, I could pull out a list of all the movies that are classified as horror in tertiary category, and then those are the ones that technically she should enjoy the most. It's also a way of looking at it. So I wanted to go deeper into the horror. I think we'll do one more thing with the horror, because there's one thing that's been bugging me, and this rating doesn't consider, I would say, number of actors or something like that. Basically, like, at the moment, we're not sure if these are like one-man shows kind of thing, or yeah, and also the year. So let's include the year again. So release year, blah blah blah. Gonna remember the group by now. Watch this. Here we go. So this is where we have to plot this in Metabase, because nobody is gonna figure out how to read this. So let's pop that over to Metabase. Let me bring that up for you guys on stream. I have to execute this. Choose visualization. Okay, this is the table. Boom, 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 boom. So we want maybe a scatter plot. Bubble size is the rating. X is the horror cluster. That could work. Or we do release year and add the horror cluster as a breakout, and the Y is the participation rate. That could work. Maybe we have to swap these around. No, it's pretty good. Let me just work out in the music. 1 second. We have to do something about that. Like this. Maybe. There we go. So what do we see? The average rating. The ratings are so close together. This is what's a bit hard. We can only scale the y-axis, so we're going to do the average participation rate, and then we'll do the average rating on the y-axis. I think this is easier to understand. And then on the y-axis we're going to do a logarithmic scaling. No, that's too hardcore. Power scaling. It just accentuates a little bit. It accentuates a little bit the ones that are further outlying, basically. Oh wow, okay, that's odd. Well, anyway, let's leave it like this for the moment. Basically, we have 3 clusters. We have the primary horror, the secondary horror, and the tertiary horror. The y-axis is the average rating, and as we already know, tertiary horror films tend to be rated higher. It's not always the case. As we see in the, if we just look at tertiary, we can see that, for example, in the 1960s, secondary was rated better. And there's not often where that otherwise happened. So no regression analysis with p-value though. No, no, I'm not able to do that, unfortunately. But that's, yeah, something like that would be probably smart to do, to have a solid mathematical conclusion as well. Also to know how certain we are about the answer and stuff like that. This stream is primarily for, I would say, entry-level people in data analytics. I do recommend looking at some of the other streams I've selected on my channel, like Carl. Carl, for example, does a lot more about subscription metrics, for example, or Nick, for example, does really advanced data science, but about sports analytics. We are pattern-seeking animals, so we tend to find patterns where none exist, says Quickende. Well, I mean, there's always a pattern to be found if you want to find one. I absolutely agree with that. We can see that the only time when secondary really outperformed was the old. And that's the exception to the rule, definitely. Otherwise, it's basically been the case that, well, I mean, maybe 2020s, it's just not so significant because we only have 1 year worth of titles to go on. But generally speaking, horror in the third category far outperforms horror in the first or second category. Now, it's kind of funny because if we can see the spacing between the bubbles between each year, or each decade rather, that spacing changes. For example, in the 1990s, we can see that all three of these bubbles were pretty close together. I'm realizing that my window is also scaled a little bit odd so that you don't see the bottom of the chart. Let me just resize this quickly. Yeah, that should be better. So the spacing between the chart is really, the spacing between the bubbles changes a lot. So there's like a bit of overlap here, for example. Yeah, Quickende, if you notice something, this for anyone on the stream, if you notice something that's visually off or something, then just let me know. Sometimes it's a bit tricky to resize all the different windows and stuff. So, but yeah, the spacing between the bubbles is really different. I mean, we see in the 1990s that the clustering here, the spacing between them, basically the distance between them are different. But yes, you said it, Quickende. The primary category never outperformed secondary or tertiary category clustered horror films, which is very interesting, very, very interesting. That may say something more about society, or it may say something about ratings on IMDb. That's what we don't know, of course, whether ratings on IMDb are actually significant or not, right? So yeah, nearing the 3-hour stream mark, definitely want to do one thing in particular before bowing out, and that is I want to look at horror from a perspective of number of actors and actresses in the movie, not by director and not by I don't know, release year or something like that, because we looked at the release year, but not by like director or something like that, but just basically people in the movie. Because it could be, I don't know if it's the case, it could be that horror movies with less actors or less people in the movie were better for whatever reason. I mean, again, we're looking at all the ratings, right? I mean, we could do other stuff as well about like number of people in the movie in general, but I think the ratings is what makes this data set kind of interesting. For sure, like we could take other data and like lay it onto this if we found something that we could merge together, for example, like, I don't know, yearly spend on film studios or who knows what, right? We could obviously do that. So this year classification is not so interesting for me, but I'll keep it in here because it doesn't harm having it in there. But we have to kind of engineer some more data from the bottom. So I'm actually going to get rid of this top bit, and I'm going to do something now. I'm going to do it in a different format. The format I'm going to use is called common table expression. Basically, I'm going to start with as a clause, and I'm going to call this my data frame. And basically this means I can just continue my query down here like this, and I can make many of these. And my first data frame is what I need to think about. So this release year classification might be useful afterwards. I don't know if I want to have it yet, so I'll leave it in there for now. I want to have the genres in there. I want to have the average rating. I want to have the number of votes. I want the number of titles as well. But I also want this actress and actor information. And that's I'm getting from the title crew. So tcr.tconst is tba.tconst. If we just want to look at this table to refresh our memory of what's in it, this is what it is. So we have number of directors and writers. This is where we might find that there's way more directors or way more writers than just 3. So what we were doing earlier with counting the commas and stuff, we might find that that's inhibitive to this analysis. The first thing I'm going to do is figure out if multiple directors is different, has a different rating than a single director. So basically single or multiple director. Purely from a personality point of view, like maybe if there's 2 directors, they don't mesh together and their vision is a bit, you know, they don't agree on the vision, and so it ends up being a poor received movie. Of course, we assume that the votes on IMDB are significant and blah blah blah. But the way to do that is basically, so we have all these genres in here, and now we have this title crew. So we have to work with this title crew table. And for that, we have, basically, we know that if there's an N, then there was no director for the movie, which I find unlikely. I think it's more of a case of they don't have the data for it. So we're just going to discount all of those rows. So directors, I should actually prefix these normally so I know where they're coming from, but yeah, they're distinct, so I'm not going to do that. Directors, again, this not equals N. For some reason I can't copy paste it, which is weird. And then what I'm going to do is basically count. I'm going to say, like, if there's a comma in here, then there's more than 1 director. I could also do it theoretically, checking the length and saying if the length is more than this ID, so 1, 2, 3, 4, 5, 6, 7, 8, 9, then I know how many directors there were. That's also a possibility. It really bothers me that you can't do backslash. Yeah, and normally it would be Option Shift 7 or Command Shift 7. It's really weird. You're back, Sharpclaw. Did you leave? I'm sorry, I wasn't sure if you had left. I mean, I assumed because you weren't chatting that you weren't here. We are about to find out whether horror movies with 1 director or more than 1 director have better ratings. What's your guys' opinion? What do you think is going to be the case? Do you think horror movies with more than 1 director are going to be better rated? Or do we think single directors, that's the go-to? So I'm gonna do it by a length because I'm lazy. So if I want to look at the length of the directors, I made it a habit of using US keyboard layout when coding, says Kwikende. Yeah, I'm on a Mac and I'm really quite familiar with it. I've been using it for, I think, 8 or 9 years at least. But yeah, I think it's just in data grip that it's not working today for some reason. It's probably some key binding thing, to be honest. So yeah, we have to do this length directors thing, and I'm gonna do it outside my data stuff that I'm doing right now. I think more than one might mean bad, because it means someone else had to fix it. Kvikende. What about Salami Rose? Seemed to be a bit of a horror fanatic. Maybe they know more about single versus multi-director. Sharpclaw, what do you think? Do you think multi-director horror films will be better? I would love to know this. Let's see. So we have, let's do it. IMDB. Title crew. Oh man, my typing is getting bad. Length directors. Count, distinct, tconst. Let's just figure out, first of all, do we even have multi-director titles? I assume that we do, because we saw a couple in there. We have to figure out what number of length equals what number of director. So each ID in title crew is this long. So a normal ID is like this, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, length 2. That's weird. Length of 2. Oh yeah, those are the ends. Okay. So where... I can just take this. So basically it would be like this. Alright. So 9 is 1. I don't know what 10... 10 is a bit weird. That means 1 comma? That's a bit odd. Why would that be the case? Makes me very suspicious. Let's look at one of those entries that are 10. Let's do that. So where and equals 10. Oh, it's actually, yeah. Comma, comma. Maybe they increased the number of digits at one point. Yeah, I was thinking the same thing now, that they maybe increased the number of digits. Yeah, you're right, they did. Oh boy, so we can't use the length method because, well, the length changed over time because they ran out of IDs basically. So we have to use a similar approach to earlier, where we looked at commas, and I think that was where did we do that? When we did the genre stuff. Where did we do that? So we actually exported the 3 genres separately. I actually think I got rid of that. That's too bad. It doesn't matter. We will extract the we will do a comma search. So we will do regexp count. Oh, we did, I remember we did length minus the other length. That was the hack that we did. But that's not going to work now. So we have to do regex count. Let's see how we can do that. So there is basically not a regex count function, but we can do basically. Vikendi says, so I asked a friend of mine and she wondered if I had an example of one movie from each decade that did well as primarily horror. I guess I should get the database myself and do the query. You can, of course, do the query yourself. I can also run it afterwards at the end. I just want to finish off this part first. But that's something I could note down to dig up for you if you want. Just let me know if you want me to do it. I can make a note and then I can definitely do it afterwards. So let me just make a note of that. Yeah, sure, it's just a query. How hard could it be, right? So we have to figure out the easiest way to extract the number of commas again. And again, we're just going to use the length hack that we used earlier, because that is basically the easiest way. So my Stack Overflow search has yielded the following. Basically, if I have the length of something, so directors, and I do minus the length replace of directors, and then my replacement string is the comma, and I replace it with nothing, then I receive the number of commas as my, basically, as far as I understand. Okay. We have to take this out. Oh, wait. Let's stop this. Oh, it already executed. 149. Wow, okay. So there's apparently a title that has 462 directors. Okay. Let's see how many titles are like that. Yeah, Weekend says WTF. I agree. If that's the case, we're definitely gonna go look at that. But maybe it's just something I did wrong. This makes sense. This makes sense. Yep, there are titles with 200 directors. Could it be that those are like crowdfunded movies? Could be. Let's take a quick look. We got to do it now that we're here. Data always raises more data questions. Select star from. I need the tconst. This is the problem. I need tconst. Let's just do star for now. So I need the tconst, and then I need to do count distinct. Oh, actually, I can just filter. Why not? Where number of commas greater than, I don't know, 300 is already ridiculous. Must have an alias, yeah. Sometimes when you create a subtable, it won't let you do anything without an alias. So now we can take this subquery, left join. This is our subquery T1, left join IMDB title basics, which is T2. This is just a temporary thing, that's why we're not doing it nicely. T2.tconst equals T1.tconst. And now we can take out T1.tconst and T2.title. Oh, come on. primary title. Here we go. Now we get to find it out. Interesting. Ah. So I already know what the answer is to this, and the answer is these are TV shows where the director changed for all the episodes over a long period of time. That is why we have so many. And actually, if you put this ID into IMDb's search box, so for example, Tatort, I'll just place this here. If you put this in IMDb's search box, you actually get the show. They actually have this ID exposed, kind of. You can just put it in the search box. You can try it out. Cool. Okay, so the number of commas is basically number of directors, kind of. At least we know that length of more than 10, so we didn't need to necessarily go to this extent, but basically any length over 10, so from 11 onwards, will be multi-director. I think that's what we found out. Let's see if that's the case. Let's just go back to this. Blah, blah, blah. Yeah, I want to do that count again, just to make sure I'm not doing something silly. Oh, wouldn't be a query if we didn't forget the group by, would it? Let's see. Little drink for me. Yep, so we've got quite a few movies, and then yeah, it's a bit fluid. I was hoping this would be less fluid, that there's a big jump into multi-director, but we're just gonna have to assume, which I don't like doing, to be honest. So we could actually replace use regex replace to take out anything except the directors, except the commas. That would be a possibility, and then we could count the length of that field. And I think that would probably work a lot better than this. And if you're not familiar with regex, so regular expressions, just a really fancy way of saying advanced search term, basically. So we're gonna do this. We're definitely gonna do this. Let me see this. All right, so we've got text, text, text. Just looking up the syntax for regex replace, because I don't want to get it wrong. Don't have it on my window, sorry. But basically, let me just put this in here so that you guys can see what I'm dealing with. So it looks like that. So we've got basically the source is directors. Our pattern is any letter from A to Z. Any letter. And it could be big or small. So we have to do like that. And we're going to replace it with nothing. So we should be left with just commas. And to see if this works, we'll just do directors. Let's see what happens. That doesn't work. Ah, yes, because it's an alphanumeric string. So AZ something. Okay, that's fine. So it's going to be AZ, and there's going to be, so this string is going to occur 2 times. Let's run that again quickly. All right, so now we have just numbers. And this occurs anywhere in the string, yeah. So then we are going to replace that occurs twice, and then there's a number from 0 to 9 occurring at least 9 times, I think it was. 1, 2, 3, 4, 5, 6, 7 times. So it's at least 7 long. And this string as a whole could be anywhere. Let's see if that works. I might have to put something after this. Okay, so it's only taking out the first one. I want it to take out the multi ones. So like this one, for example. So I want this, and this can occur. So this could then be followed by a comma. Oh, now I need those backslashes. So Kvikende says, are you based in Switzerland? Yes, I am. I am based in Zurich. So double backslash comma. Oopsie, wait a second here. We have a little boo-boo. This doesn't belong. So this would be 7 or more times, and then this whole thing could be followed by a comma, and this whole string could occur multiple times, but let's just try that out. Maybe it will do all of them. No. Didn't like that. Regex is a bit finicky. Or so Kvikende says, I'm starting to think if you aren't going into pumping lemma territory. Yeah, it's a bit complicated to figure out the number of directors, but basically because they changed the length of the ID, it's impossible to know. But you know what? We're going to do the nasty way, and we're just going to assume it's correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if there is something that is basically 9 or 10 length, then it's single director. And anything above 10 will be multi-director. And it's expanded this to directory. I think that's where we're going to go with that, because that's just the way we're going to do it. This is pretty advanced. I'm not going to finish the regex today, probably. So, because I'd like to figure out if multi-director horror movies are better, that's what we're going to do. So, let's do it. 0 to 9. Can't you do 0 to 9 dot double slash? Probably. Dot can be an operator, yes. But I'm just going to do the easy way. I could get the regex working if I had a little bit more time for the pattern, but it's not so important. Basically, we're just going to take this as the truth. And so we go length directors, we do case when, our trusty case when friend, Case when, is that the same length? Oops. Assume even though it's wrong. I don't think it's necessarily wrong, to be honest with you. I think there's a certain significance in it being correct. I don't think it's inherently wrong. I think it's the fast way, but I don't think it's inherently wrong. I think it's just the faster way. There may be a small margin of error. It's definitely possible. But that being said, how often is it going to be wrong within this horror category, right? We always have to think about that. It's inaccurate, but it does the job, yeah. In this particular scenario where I'm just going to try and finish the stream for today, I might come back to this later in my own time and figure out the regex and just compare and see if it was utter rubbish, which I probably will do tomorrow. But so when the length of directors is less than 11, then we're going to call this single director, and else multi-director, and then end, what should we call this? Directorship. I think that's a great name. Let's pop that up here. So we now have release year, genre 1, genre 2, genre 3, directorship, and then the ratings. We need to add another group by statement in here. Let's see what this data frame looks like now. So this is what the data frame looks like. We have the release year, the genres, the directorship. We're just going to look at the directorship, because that's what the people want. Average of the average rating. So this is the average rating. And we want the sum of the votes. And we want the sum of the number of titles. So this is the sum of the, we just call this number of titles. And now, Quickende says, it's a common thing that you get bogged down into getting details right when it doesn't matter. Not finishing a novel because you can't get every comma placed correctly. I mean, there's a fine line between, at least in data analysis for me, there's a fine line between it being inaccurate and unusable, and inaccurate and still okay, acceptable. So yeah, I think now is not the time to go into a lot of detail, but it's something I'm going to double check later. So we got here directorship, average rating, number of titles. We should do the thing we did before with the party rate. Was basically just the votes over the titles. So the sum of the votes actually we totally don't need the actual raw numbers, to be honest, so we'll just take those out. Okay, I almost forgot the group by, but I didn't, which is a good sign. That means it's definitely close to logging off for the night. Let's see what happens. Oh boy. So, to some extent, the theory is correct. The question was, are movies with more than one director less well rated? Basically, yes. How do you guys feel about that result? I'm not surprised by it. It does make sense in terms of vision that multiple directors would be more yeah, would maybe argue more often about the direction the movie is taking. So that's kind of funny. That's one aspect. One aspect to this, someone else had to come in and fix the film. Yeah. I mean, yeah, maybe. I mean, maybe. The spread is not huge. It's not a huge difference. Funnily enough, the number of votes per movie is much higher in the single director. That may just be a factor of the spread, though. That may just be inherently the data being that way. One thing that we can just add before we call this a day is the release years. Maybe multi-directorship. You showed that it had TV shows. Yeah, we've taken that out by just filtering by movies here up here. We were just doing a sort of subquery before. Here we're just looking at horror movies. In a TV show context, this would have to be a different analysis because we'd have to take them apart by season or even by episode or something like that. If that's something you'd like to see, Kvikende, you can slap it in the suggestion box. You'll find that in my about, in my profile. There should be an extension there that allows you to put suggestions in there. Also, if you have suggestions for the stream, let me know what you think. But yeah, here we're just looking at movies. So I think I would like to include the release year because maybe the decades were different. And then that's what we're going to put in Metabase, and just going to bring that up for you guys. And based on that, we're going to run the query. And then, oh, it doesn't like this. Ooh, it doesn't like this at all. Let's try again. Okay. Sometimes it gets a bit lagged out because I'm running it locally. Alright, so SQL, Postgres. And should support common table expressions as far as I know. Alright, here we go. So, what do we want to see? I think scatter is not bad. We could do a row thing as well. Y-axis, release year groups with directorship and average rating. Oh wow, okay. That doesn't work. That's weird. Bar? Oh, okay. So interestingly enough, the row doesn't work, but the bar does. So we have each decade. You can see this okay on stream? Yeah, it looks alright. You can see each decade and then multi-director and single director. Was there any decade in particular where single director massively outperformed? Yeah. 1980s? That gap is big. 4.89, 5.43. That's pretty big. What's interesting is that this is changing. At least for 2020. This is changing. And in the 2000s, actually, this was already the case that multi-director outperformed a little bit. So overall, it is correct what we wrote. Overall, movies with more than one director are less well rated. But, I mean, okay, it's not a huge difference, right? 5.38 versus 5.27 with like 1,500 votes per title. It's not a huge spread. but it's not the same every year, every decade rather. But yeah, this is just an example. I mean, it's not definitive, as we saw, and also like the spread of how many directors. I think there's like primary directors and then like less involved directors and stuff like that. I don't know too much about movie making. It would be cool to have someone in here who knows a little bit more about movie making, but yeah, I think so. Looking at this, I would summarize it as basically yes, but the results per decade differ slightly. So that was the crew question answered for me. I would probably want to go further than just the crew and actually go into the name table, where I actually have each title that they are known for. So I would link each talent or each person that was involved in a movie to that movie, and basically I wouldn't be able to take their profession because this is the profession that they have as a person and not within each title. Yeah, I wanted to do your question, Kvikende, before we log off, as it is getting late. So the question that you asked, we're going to put that in a fresh query. So example of one movie from each decade that did well as primarily horror. That's what we know. That's easy enough. So we already have a beautiful query here. We already have basically everything we need here. All right. So this gives us, what does this give us again? Forget what this gives us. Release year. Okay. So one movie from each decade, that's fine. That did well as primarily horror. Okay. So we do where genre 1 equals horror. That's fine. That did well. Kind of a subjective question. Kvikende, what do you mean by did well? Just had a good rating? Because we could just exclude those from there. Average rating. Group by 1, 2. Order by 3. Oh, what's it doesn't like here? Aggregate function is not allowed in group by. Oh, whoops. Yeah, we only need 1. So we've got yeah, so these are basically each decade. If I was going to do it properly, I would do a window function, but that's going to take a little bit too much time to partition and rank each decade. So what I'm going to do is just do the manual version. So I'm going to call this data frame as, and I mean, have your friend join the stream next time. Maybe we can go into movies again next time. I don't know. Depends on what people want. So where I need to just include the rating. I don't need the votes anymore. And I need to take tba.tconst and tba. Let's take the primary title. That will help us see what we're looking at. Yeah, no more group by. So if we want to take the top one, we'll just take the top one of each. Yeah, of each decade. It's kind of interesting that. Yeah, right. So basically, data frame where release year group equals 2020s. So you see, like, basically each group could be its own window function with a rank and stuff like that. Basically, we're just gonna, so for the 2020s, we're gonna do like that. I'll just export this afterwards. Now we do 2010s. There we go. Okay. I'm just going to repeat this for each decade. It's basically the top ranked one for each decade. Probably could have done this faster. Oh, absolutely. I'll copy paste it into chat. Then you can just send it to her. So 1990s. We could do it through the window function, but yeah, I'm just a bit too tired to do that now. So, not so smart contract. Thank you for the follow, much appreciated. If you're enjoying the stream, let me know. We are about to log off for today, but I should be on again on Monday. Will we look at movies again? I don't know. Depends. Maybe. Not so smart contract. What's your favorite part of the stream today? Is there something you enjoyed in particular? Would love to know. Maybe there's something I can change to make it even better for you guys. As I said, I primarily do this out of self-interest, but of course I want it to be entertaining. So this is back to the 1950s. I think we can also do the old ones. Why not? It's actually a classic, The Invisible Man. Well, for starters, you're not a game developer. No, I'm not. Why do you... Oh, I see. That's my favorite part. Are you tired of watching game developers on Twitch then? There are a lot of game developers on Twitch, but gaming is huge, and Twitch is about gaming. So yeah. But thanks, I appreciate that. No, I'm not a game developer. Twitch is definitely full of them. So, Quikende, you asked for this, you shall receive. It's not very pretty. I could snap this into a code pen to make it a little bit nicer. What's it called? I thought there was a free one. Oh, okay. You can fix it. That's fine. I was pretty sure that there were free ones, but yeah. Was pretty sure that there was a free one. Oh yeah, fiddle. But that's fine if you or paste bin, that works too. Yeah, it's not a huge deal. If you can fix it, that's great. So this is kind of funny. This is basically the top 10 horror movies by decade. I mean, top 1 by each decade. I'm actually a bit curious about this first one because I seem to remember this being not a horror movie. Oh no, okay. Yep, it's a horror movie. A small town is terrorized by a mysterious monster with glowing eyes. So, not so smart contract. Do you also use other databases, Postgres, MongoDB, etc., and graphs like GraphQL? So, I'm currently using Postgres. This is Postgres that I'm using here. I've been using other databases before, like Redshift, MySQL, anything really. Doesn't matter so much. Microsoft SQL Server. Graphs, I haven't looked into stuff like GraphQL. I mean, I know about them, or D3, for example. D3, I mean, like JavaScript-based ones. Today on the stream, I've been showing using something called Metabase, if you're interested in knowing about that. That's basically a combination between BI and SQL engine, because it allows you to write SQL and, of course, to explore data in a BI kind of visual way. So, for example, if I browse, I don't know, let's say IMDB, title basics, this is my title table, and then I could start visualizing it. Obviously, there's not a lot you can do here. You could summarize and say, I don't know, count number of rows, and then it tells me, oh, this is how many rows I have. Okay, great. And I could take, I don't know, title type as a filter, and then I get lots of TV episodes, 563,000 movies, etc. Yes, sir, I'm interested. Thank you for showing. Yeah, no problem. So I will probably use Metabase in the future again as well. I've used it a few streams ago. It's not. I don't use it every time. I'm a front-end developer who is trying to be full stack. Wonderful. Then things like the backend will interest you for sure. I mean, this Metabase can be hosted on pretty much anything from what I understand. Here I'm just running it in a Docker environment. I'm also a UI UX designer with branding and marketing skills. Yeah, that sounds like you're sort of the development full stack kind of person, at least from a sort of website or online product point of view. The same thing that I am from an analytics point of view, full stack analytics person. So yeah. We were looking at horror movies today. At the end, at least, we were looking at a lot of different movie things. And so at the end of the stream, I like to just go back to just quickly run through what we looked at. Did movies get better over time? Technically, yes. So since the 1970s, movies did get better. But yeah, older movies like pre-1950 had good ratings. 1950, 1960, they also had good ratings. It seemed to be in the 1970s that movies were not that great. There could be a lot of other reasons for that too, but yeah. Which genres have the best ratings? Documentaries, biographies, and music tended to have the best ratings. That being said, we discarded a lot of results where the genres was unknown, and I'll dare to say The Shining is overrated. Look, voting is very subjective, as we know. So this is pretty interesting, but yeah, I mean, at the end of the day, this is what is reflective of public opinion, I would say, at least on IMDb. So yeah, that's quite funny, I would say. Not for Redditors. Yeah, I mean, there's a lot of opinions on the internet, let's say. What else did we look at? Are older horror movies better than new ones? Generally speaking, yes. That is true. And does the order of classification of a movie as horror change its likelihood to be rated lower? We also found that that is a factor. So if a horror movie is primarily classified as something else, it's less likely to be well rated. Yeah, it's a bit funny one. I probably have to look at that one again at some point. Are movies with more than one director less well rated? So we just looked at horror movies in this case. The answer was basically yes, but the results per decade are a little bit different. That's something that probably needs a bit more time. So like we come back in 2030 and look at that again, if you guys are still here. And one example of one movie from each decade that did well as primarily horror. Let's take the top result. That's a bit quiet. So I just put on a little bit of a different music to end the stream here. So that is what we looked at today with IMDb records. I hope you found the stream today interesting. If you've been here since the beginning, congratulations for sticking it out. If you've just joined midstream, then I will hope to see you next time, probably Monday, where I will be most probably doing something else than movies. Probably something else. We might not do pure data analysis. We might do something a bit different. Maybe more about data collection in the front end. Not so smart contract, that might be something up your alley. If you're a front end dev who's trying to go full stack, might be interesting to see data collection in the front end, and then what kind of effect that has on data analysis then in a database, for example. We've been speaking about time series data a lot. So I don't know, I still have to think about it. But Monday should be the time and place for that. It's already in the schedule. If it does change, I'll update it in the schedule, but that shouldn't be the case. But I tend to decide relatively last minute about the topics. Yeah, I would have liked to go into more detail about the names, but I think we got out quite a few nice bits and pieces here from this. So thanks a lot for joining and sticking it out. A fellow streamer, if you're interested in data analysis, Carl should be coming online soon. I actually would have liked to raid his channel, but you can only start a raid with 5 viewers or something like that, and I'm not at that point yet, let's say. So if you are interested in data analysis, he's doing a lot around churn, so subscription metrics and churn, which I find very interesting. So if you come from a product background, or if you look into subscriptions for whatever reason, I mean, there's tons of SaaS tools around, then do check out his stream. He should be starting in about 15 minutes, I think. So that's it from me. I hope you have a good rest of the weekend, evening if it's for you, morning, afternoon, what that may be. And thanks for tuning in, and maybe hear you next time. Thank you, Not So Smart Contract. Bye-bye.